lab, try again.
Hello, and welcome back to Pi Cascades. Thank you for making day one a success. Here's to making day two a success as well. Logistics, same as yesterday, same Wi-Fi information. We still have restrooms located upstairs and downstairs, and we do have a gender-neutral bathroom available as well. If you need access to that, please reach out to me or any of the staff members. We can get you access to the green room. Refreshments are still located upstairs in the Walker Ames room. And the quiet room is still next door, room 120. We are streaming all the talks there, so if you want some quiet time but you don't want to miss the talks, you can still see them in the quiet room. There will be closed captioning available, so you still get to enjoy all the content. There's still no food or drink allowed in the auditoriums. Please be respectful of that rule. We do have a code of conduct. In short, be excellent to each other. If you do feel that the code of conduct is being violated or you feel uncomfortable, you can approach any staff member and we'll get you in contact with a code of conduct member. We do have a code of conduct hotline. You can call or text that number. It will page all of the people in the code of conduct committee. You can also email the conduct at Pi Cascades email account that will also go to the code of conduct committee. And if you have any issues with any staff members or anyone else, you can always contact me or Thea as well. And then if you want to read the full code of conduct, which I highly recommend you do, you can find it at that URL below. We have a photo policy. It's pretty simple. If you see someone with a purple lanyard, they're okay with photos being taken. If you see someone with a white lanyard, they're not. So if you do take photos and there's someone in there with a white lanyard, please remove the photo, and especially do not post that to social media. I'd like to remind everyone of the Pac-Man rule. We are a community conference. We're here to network, meet new friends, and have fun. When you're hanging out with some people, you're having a conversation, people tend to group up in a circle. Just leave a little bit of space open for someone to join the conversation. Meet a new friend, learn something new, and have fun. Schedule and talks, same format as yesterday. We have 25-minute talks, 5-minute break in between. We're not going to do Q&A. Lunch is at 12:35 to 1:50. If you got lunch yesterday at the hub, it is closed today. So you'll need to find a different spot. Luckily, there's plenty of other options nearby. If you want some help finding options, I would recommend joining our Slack team and asking around there. There's plenty of people who know the food options around here, as well as the Welcome Wagon has a lot of information for local restaurants. Conference ends at 5:35 today, and the full schedule is on our website. We do have shirts for sale. They're outside next to the registration desk. They're $20. It's next to Nexmo. If you did volunteer, or you're going to be volunteering, or if your badge says staff on it at all, just go to the registration desk, get your free shirt. Even if maybe you were just, you were on the schedule but we didn't need you, you still get a shirt. Thank you for volunteering. They're available all day. I do have some other announcements. There are some free books in the lobby, a limited number, but they're from Manning. They're deep learning books. First come, first serve. Please don't start a stampede. We are going to be doing some announcements after the lightning talks. Twilio is going to give away some goodies for people who participated in the Twilio Quest event. And then, oh, I already said the hub is closed. So just want a big thank you to everyone who came out today and yesterday, as well as all of our sponsors, Heroku, Nexmo, Google, Manning, and all the other ones I unfortunately may have forgotten. Sorry, I'm very nervous. And now that I'm done, we can start with our first talk of the day.
Good morning. We're going to start the day off with Nina and a talk about lighting up your life, Python and LEDs.
Okay. Can everyone hear me? Awesome. Good morning, PyCascades. I'm Nina Zakharenko. I've been a software engineer for over a decade now. I've written code for a few companies that you might have heard of. I've worked at HBO, Meetup, Reddit. Today, I work as a senior cloud developer advocate at Microsoft, where my goal is to make Azure a pleasure to use for Python developers everywhere. The slides and code are available online, so grab a copy if you want to follow along. There are a lot of links and helpful resources available. If you grab them on Speaker Deck, just know that you have to download the PDF for those clickable links. And there's code available as well, git.io/techtalks. Let's try something a little bit fun in this talk. If you're learning something new that you're excited about, please share a tweet. You can use the hashtag PyCascades2019. You can @mention me as well. I'm NNJA on Twitter, like Ninja, but without the I. If you see anything, if you see anything exciting, share. So let's dive in. I want to cover where to start when you're just getting started. So what kind of different hardware options you might have, programming LEDs, how you might debug your hardware with print statements, the kind of tools that you might use, and libraries, and lastly, what kind of projects. And if I can get it working, I also have some live demos to show. I brought this kind of portable camera setup for the very first time, so we'll see if the demo gods will shine on me today. Okay, so I've been doing software for a long time. I only recently started playing with hardware. These are some of my projects, and I kind of instantly fell in love. I feel like software has this ephemeral nature to it, and you can't hold it in your hand, you can't touch it, and hardware is a little bit different. You can kind of create a physical manifestation of your code. And so I love the idea of LEDs. I really liked making kind of cool wearable projects. I made this headdress. I wanted to make pretty things that fit my aesthetic, which got me interested. Hardware lets me be creative. It lets me imagine something and then bring that imagination to life. And I've been inspired by a lot of amazing shared projects and documentation from other makers, people like Becky Stern and many others. So your hardware options. There are quite a few. I'm only going to cover 3 briefly. The Raspberry Pi Zero W, it's a small development kit, has a wireless and Bluetooth connectivity. And let me breeze through these and I'll show you a picture instead. So here we go. On the left, that's the Raspberry Pi Zero W. It's got wireless connectivity, Bluetooth. This is the range of devices, or some of the devices that run Python. In the middle is the BBC Microbit. It's a computing device aimed at learning, and it was given free to every child around the age of 11 across the UK in 2016. Adafruit has a lot of devices in the M0 and M4 lines, and there are many more that I'm not going to be covering today. What I will be focusing on is Adafruit. I'm not affiliated with them in any way, so this is not a sales pitch. I'm just a huge fan, and it's a woman-owned company based in New York. Adafruit products are low cost, they're easy to order, and they're also very well documented. This is kind of maybe my favorite Adafruit thing. It's the Hollowing M0. It's a spooky development kit, and it has a 1.5-inch screen on it. And I have one with me if anybody wants to take a look at this close up. So I'm not the only one who thinks that hardware is cool. 90% of students said that the microbit showed them that anyone can code. 86% of students said that the microbit made computer science more interesting. And maybe a little close to heart for me is that 70% more girls said that they would choose computing as a school subject after using the microbit. Now, here's what we're going to be focusing on today. It's the Adafruit Circuit Playground Express. Depending on where you purchased it, it may come with Python installed by default. If you picked up one in the Microsoft booth at PyCon US last year, that does have Python installed. But if yours doesn't, it's pretty easy to set it up to run Python. And I'll show you how. It's my favorite option for an introduction to electronics and programming hardware. So PEP 206 says that the Python source distribution, it's maintained this philosophy of batteries included. So having a rich and versatile standard library which is immediately available without making the user download separate packages, it helped drive Python's success early on. Now, the Circuit Python Express doesn't actually come with batteries. But I imagine that the same philosophy applies here. It has everything that you need to get started programming hardware, just included on one board. So here it is. What's on it? There's 10 NeoPixel RGB LEDs. They're kind of on that ring around the outside. Each one can display 16 million colors. There's a light sensor, a temperature sensor. There's programmable buttons, a left and right one, and a switch. There's an accelerometer to detect motion, a mini speaker, a microphone. It has input and output via the pads around the sides, and some of those support capacitive touch. There's 2 megabytes of flash memory, so your programs are saved even if it's not connected to a power source. You can store small files there like sound clips, and there's micro USB on it, which makes it easy to program. And lots of other stuff. The best thing about it is there's no soldering required. You can easily connect other things to it if you want to with alligator clips like LED strips once you're kind of ready to explore more. Now, there's two variants of Python that run on hardware. There's MicroPython. It's a variant of Python 3 that's designed to run on microcontrollers, and it's really compact. So it's compact enough to fit and run within just 256K of code space and 16K of RAM. It's what runs on the microbit. There's also CircuitPython. CircuitPython is an education-friendly fork, Adafruit fork of MicroPython. And both are open source, but since I'll be showing my demos on Adafruit hardware, we'll be using CircuitPython. There are a few different CircuitPython libraries available for programming LEDs, interacting with sensors, et cetera. Some of them are built in, some are not, and you'll need to move them into a lib folder on your device. We're particularly interested in the one for the Circuit Playground Express that lets us interact easily with the board. And let's see how that might look. So here's an example. There's the two buttons. You can kind of see they're labeled A and B. We can access this, once we import the Circuit Playground library, CPX, we can access them with cpx.button_A and button_B. Those variables will be set to true when the button is pressed and false when it's not. Now, you need to understand a little bit about RGB LEDs to really get a good idea of how they can be programmed. So an RGB LED is just a collection of 3 LEDs in one package. RGB stands for red, green, and blue. And if you look at the color wheel on the right side, you can see that you can produce almost any color by combining these colors in intensities varying from 0 to 255. So 0 would be 0% intensity, 255 would be 100% intensity. 0 means that the color is not present, but 255, if we set blue to 255, for example, that would show all blue. I think it works a little bit better if you can see it. So NeoPixel is an Adafruit brand for individually addressable RGB LEDs, commonly the WS2812. The tiny LEDs within the NeoPixel, they're lighting up individually, but your eye sees them as one color because they're pretty small, right? So if they're all turned on, and you can kind of see the color around the outside of the ring. If they're all turned on, the LED will display white. If they're all turned off, the LED will display black, and based on how they're programmed to turn on, they can display all the colors in between. So here's a simple program that cycles through red, green, and blue LEDs with a button press. Let's walk through it. So the first thing that we're doing is importing just time from Python, and also CPX, the Circuit Playground Express library. We're setting up our colors with RGB values. Now, notice where the 0s and 255s are here. For example, for red, just 255 in the first position, 0 for the rest, etc. I'm making a list of all the colors that I want to loop through, and I'm starting with a position of 0. I'm also setting the brightness here because the LEDs are very bright. So if you use this code, I don't want to blind you. Next thing I'm going to do is I want to, instead of just running our code once and then stopping, we want to loop forever because we want to be constantly checking for input. I constantly want to know, I constantly want to be checking if either of the buttons are being pressed. Now, I can use that cpx.button.A or cpx.button.B to listen to button presses. So if either the left or the right button is pressed, change the, pick the new color. I'm using modulo here to kind of wrap around the list, right? So we just start back at the beginning if we run off the end. And I'm sleeping for just 1/5 of a second because that helps prevent picking up multiple button presses. In other types of hardware, this idea is called debouncing. Okay, actually, I'm going to go back here, and let's see if, can everyone see that? Is that big enough? Okay, so I just have that here. Let's see. So all the red LEDs, you see the 2 buttons here. If I press either of them, it changes color. Pretty cool, right? All right, well, let's try to add a little bit of code to this. I'm not mirroring my displays, so I'm just going to have to bump this up really big. So, close that. We have our RGB here. Let's add some new colors, so purple. Purple is a combination of red and blue, right? So that would be 255 for red, 0 for green, 255 for blue, and yellow is green and blue, right? So that would be 0 for red, 255 for green, 255 for blue. And let's do one more. Let's do a cyan. So cyan is green and blue, right? So, oh, did I mess up my yellow? Okay, so yellow is my cyan, right? And we're doing green and blue, right? Red and green. Thank you so much. So that would look like that. And now I have some new colors. Yeah, got that. So that's my yellow. And now let's add these to my list here. We got purple, and we got yellow. And I'm going to save it, and let's see if this works. So now I have my red, green, blue. There's my cyan. And there's my purple. There's my yellow. Cool, so it works. Let's see. All right. Let's get that out of the way. And then I had a video just in case it didn't. But all right, so how do we program this thing? It's a lot easier than working with Arduino-based platforms. For those of you in the room who have tried it, that means no AVR dude errors. Those, yeah, there's a few knowing laughs. So you plug it in with data in charge on the USB cable. If you see a CircuitPython drive, great, you're kind of done there. On Mac, it'll be in volumes / CircuitPy. Otherwise, you need to go and install CircuitPython. Next, you edit your code and save it, either in a code.py file or a main.py file, and then your code will run instantly because it's being auto-reloaded. Just know that you don't want to unplug or reset the board before your computer finishes writing the file to the board because that can corrupt the drive. You want to wait until the file is done being saved before unplugging or resetting your board. That can take about 30 to 90 seconds, depending on your editor. So I just made a quick little video of how you might, if you don't have CircuitPython already, this is how you would install it. You grab the, I believe it's a UTF file from the Adafruit website, and you need to double press on the reset button, the tiny kind of, I'll show that again, the tiny reset button in the middle of the board until it's green. That means it's kind of ready for input, and then you can just drag and drop that file and into the cplay boot drive that will show up, and then it'll turn off for a second and CircuitPython will be ready to go. Now, what editor can you use to write the code? The safest bet is an editor that writes out the file completely when you save it. So it does the smart thing, it writes out the full file, you don't have to worry about waiting to save. I love VS Code for this. It's already the editor that I use for Python. It has great autocomplete, an integrated terminal, and a lot more. There's also the Mu editor. It's a simple Python editor designed for beginner programmers, and it has awesome support for the Circuit Playground Express. All you have to do is click on Mode in the top left over there. It's cross-platform, and it takes a lot of the pain out of configuration. Something that I'm super excited about is a brand new guide as of February 2019 for how to use EduBlocks with the Circuit Playground Express. How many of you know about EduBlocks? Yeah, that's awesome. So for those of you who don't, it's created by Joshua Lowe, who's just a brilliant 14-year-old programmer. He did a talk at EuroPython last year about a little bit about himself and mostly about EduBlocks, so I recommend that you watch it. He's so inspiring. EduBlocks is a Scratch-like drag and drop interface to Python, but there's Python 3 under the hood, so you can view your code visually or you can view it in a tab that just has all the Python code laid out, which is awesome, right? You can switch between the code and the blocks, so it kind of helps you learn, but then it also helps you graduate. And the integration with the Circuit Playground Express is still in beta, so make sure that you try that out. Okay, now, what if something's going wrong? It's going to be helpful to see what's going on with print statements. Here, I updated my program to add some labels to my colors because I want to keep track of the previous colors and the next colors. So I'm just adding those labels. Next, I'm looping forever again, and I'm just grabbing the name and the color, the label and the color from my data structure there, listening for button press. But the most important thing here is I have a print statement now. And printing out what color I went from to the color I'm going to. The important thing here is you need to view these print statements and errors via the serial console. You need to communicate with the Circuit Playground Express to see those print statements. The serial console receives output from your CircuitPython board sent over USB, and then it takes it and displays it so you can see it. If you don't connect to a serial console, you're actually not going to see anything. You won't see any output. This is really helpful for troubleshooting errors because your board will send errors and then the serial console will print those too. The easiest way to do this is with the Mu editor. Once you pick the mode of CircuitPython, all you need to do is click on the serial button in the toolbar, and that's it. So if you're kind of unsure, this is the guaranteed way to go. And just a quick demo of that. That once, as I press the button, we'll see that in the serial. For the advanced serial console on Mac OS, you can use a terminal app and a screen program or plenty of other kind of standalone apps to connect to the serial console, like CoolTerm. All you have to do is list your devices and then connect to that serial console with screen. In the example here, 115200, that's the baud rate. I like using VS Code, the integrated terminal for this, and you could kind of see a demo of that here. Actually, should we try this, see if it works? Yeah. Okay. Let's go back. All right, let me just switch out my devices because I have the updated code on the second one. Okay, so this is my updated code here. We'll see that there's a print statement. And I'll open up my integrated terminal. And let's see, I want to list out my devices. And we'll see here I have the USB modem. That's the one that I'm interested in. Excuse my typos. I'm like trying to figure out what's going on from this other tiny screen. Okay, so now that we have that, we can connect to it. Make sure I got the full string. Oh no. Oh, thank you. I love pair programming with a room full of people. All right, see, that looks like it's working. Cool. I also have a handy guide to quitting screen for those of you who might need it. All right, so how do you power your projects? USB is probably the easiest option. You probably already have a micro USB cable somewhere in your house and like a phone charging battery. You can even plug it into the wall or plenty of other things. For battery packs, they have to have a JST connector, and you need a minimum of 3.5 volts DC to power the Circuit Playground Express. So you can, each AAA household battery is 1.5 volts, so if you put 3 of them together in the right enclosure with the right connector, that's a great option for powering your projects on the go. You can also power your projects with LiPo batteries. So just a fair warning, they're for advanced users only. They're small, lightweight, but they're very energy dense. They have a lot of energy in a small package, but they're for advanced users only because they're very fragile. They can be dangerous if they short or are damaged. They need a lot of special care. The Circuit Playground Express, so they can't be heated, punctured, or bent. It's so not for kids without supervision. And the Circuit Playground Express does not come with the charging circuitry for these LiPoly batteries. So you'll need to buy your own charger. So putting it all together, there's Adafruit demo code. I posted the code that came with my Circuit Playground Express that did have Python on it. There's an initial directory link there as well that has all the library files. The demo covers the majority of the features, and it prints out sensor readings, et cetera. It might be a little bit out of date, but there's even a flag set so you can turn on the Playground Express and turn it into a little piano using the capacitive touch pads. And I brought that with me, so. So if you can kind of see that, I set it so when I switch it on. Can you hear that? Yeah, okay. I didn't write this code. This is all Adafruit, but it's there and available for you if you want to check it out. So just a few other quick housekeeping things. Microsoft MakeCode is a great option. Coding is not required. So if you want to start programming hardware with zero programming knowledge or zero coding, Microsoft MakeCode is a block-based editor here. You can export as JavaScript. You can have cool collaborations. There's one with Cartoon Network. One of the projects is making a glowing gem from Steven Universe, which is, I love that show. And you don't even need a device. There's kind of an emulator right there on the left-hand side so you can see what's happening. The hardware community is really awesome about sharing projects, incredible projects with just step-by-step instructions. So there's Adafruit guides, there's Microsoft MakeCode. Instructables is also a great resource. On the left here, there's a jack-o'-lantern project with the Circuit Playground Express. All you need is the board, some batteries, and a Ziploc bag if you're going to be using a real pumpkin. And there's a link to that up there. So, okay, next steps. Buy or borrow a device of your choice, or use an emulator. Pick your editor, like Visual Studio Code, Mute, et cetera. Write your own code, use the library, start with someone else's project. The choice is yours. You'll get started with Python on hardware in no time. And I brought one of my projects. So I think you'll see now that Python opens a whole new world of working with wearable electronics because my earrings run Python. And Scott is here today. He's the maintainer on CircuitPython. Find him. He's got a lot of cool stuff. If you'll be at PyCon US in May, stop by the Microsoft booth. We'll be giving away more Adafruit kits for completing coding labs. And as a special surprise, Adafruit will be including a Circuit Playground Express in your PyCon US swag bag. All right, that's it. Thank you so much for having me today. I hope you're going to leave inspired. If you want to take a closer look at hardware, I have some with me. If you want to learn more about Python at Microsoft, the link is up there. Follow me on Twitter, check out the code, and that's the mascot for my team, Developer Advocate Bit. So if you think that's cute, find me in the afternoon for stickers. Thank you. Sorry. Oh my God, turn off.
Our next talk will be by Dustin Ingram about data protection for developers. Seems pretty topical.
Hey, everybody. Can you hear me? All right, great. Hey, so, oh, crap. All right, I got to get rid of this cookie policy. Hey, all right, so my name is Dustin Ingram. This talk is called Data Protection for Developers. First things first, I have a few disclaimers, all right? Hope that's scary enough. The first thing is, I'm a developer advocate. I am not a lawyer. This might be confusing to you if you speak another language. Advocate, lawyer are often the same thing, but I'm not. So don't take anything I'm about to say as legal advice or policy advice. I also work for Google. This talk is not about Google, so I'm not promising that our products are GDPR compliant or that they provide like a GDPR fix or like a silver bullet, because they definitely don't. The last thing is, I love Python. I'm one of the maintainers of the Python package index. I organize PyTexas. I've given a ton of talks about Python. This is not a talk about Python. This is a talk about my interests at an intersection of technology and law, and it's about something that's kind of been building up for a really long time, and it's kind of coming to a head now, but not a whole lot of people know about it. And that thing is data protection. So first, before I start talking about data protection, I want to just talk about data. Like, what is data? We're talking about big data, small data, medium data. Generally, a data is just like a collection of values for one or more variables. It's discrete pieces of information. It comes from the Latin root datum, and this is kind of important. It means, it comes from datum, which means something that is given. So, for example, let's say I invite you all to a pizza party, and at the party, I start counting how many pizzas we all eat at the end. You might be like, okay, that makes sense. But what if I was counting like the individual number of pieces of pizza that each of you were eating? You might be like, that's kind of creepy and weird, Dustin, why would you do that? And there's also kind of an ethical issue here. Like, is that data given to me, or am I taking it from you? And whose data was it, really, right? So some people that work in data protection like to use the word capta instead to describe this kind of data that is taken. And capta comes from the capere, which is the same root as capture and captive. And you might have also heard of personally identifiable information. So this is another type of data that's really specific to one person that can be used to identify that person or just simply belongs to a single person. So for the purposes of this talk, I'm just going to be talking about personal data, any data that is about you or that you generate, both data and capta. And we're going to start in Germany. Germany might not be the first place that you think of when I'm talking about the birthplace of data protection. But Germany was kind of an interesting place right after World War II. It's kind of like Twitter these days. Many citizens were having a really strong reaction to their previous government. They wanted to ensure that a potential dictator never again had the chance to come to power in their country. But you can't just pass a law that says, no Hitlers. But what you can do is pass laws that prohibit the things that give Nazis power, and which make the things that Nazis like to do illegal. So in 1949, Germany got the Basic Law, and this had two key tenets. First, a person's dignity is inviolable under all circumstances. And second, each person has the right to develop their personality, as long as it doesn't injure or interfere with the rights of others. So personality is kind of a funny word here. In German, it's actually this, which I'm not going to try to pronounce, but it basically means rights of the personality, or the right to be yourself and do things that you want to do. So there were some other concerns that Germans had increasingly in the 50s and 60s. So one was nuclear power, kind of scary nuclear power. Second was pollution, a lot like we are today. And the third was data privacy. And all three of these have something in common. They all concern the same thing, the acceptable use of some new technological development, right? Each of these things has so many complex and interconnected parts that one individual cannot possibly grasp all of the issues involved. And for data protection specifically, this comes from two places. One, the Germans saw the increasing use of computers, and two, their history, right? As a nation, how did the Nazis know who were Jewish? They looked at census records, tax returns, synagogue membership lists. All of these were seemingly harmless data that their government had collected on them. So in 1979, one of the states in Germany, Hesse, passed a law called the Hessian Data Protection Act. And this was more legislation on top of the basic law. And the name is kind of a misnomer. It didn't actually protect data. It protected the people whose data was being processed. And it was only concerned with data ex ante, data, what was done with the data after it was collected. It wasn't really concerned with how data was collected or who was collecting it. And it was only really focused also in the public sector. So the processing of data in the public sector. The interesting thing this law did was it created someone called the Data Protection Commissioner. So this is a person that was charged with overseeing any violations of this Data Protection Act. And kind of ironically, this first commissioner was actually kind of a dictator himself. He held the post for 16 years. But this is considered to be the very first Data Protection Act ever. And this was 1970. This law might seem kind of primitive. It was only focused on the uses of data, nothing about encryption or breaches or anything like that. But this, the Enigma machine, was the best that we had in terms of encryption at the end of World War II. And it wasn't even until 1975 that we had our first encryption standard. So this is actually pretty good. Like, this is really progressive. Around the same time in Sweden, they had a completely different set of circumstances that were leading up to similar data protection laws. The Swedish government started using computers way before a lot of other countries. They had a really small population, they had really high standards of living and income, and they could kind of foresee the usefulness of automation that computers would provide. Sweden at the time was called a paradise for registers. They had vast amounts of information about its citizens. So it was said that the average adult would appear in 100 separate data systems, 200 if you were married, and that might not seem like much to us, but you might have like 100 apps on your smartphone. But this was the 1970s, so that was a lot. There was already kind of this notion of a strong notion of the right of public access based into the Swedish constitution. And this generally meant that the public could be present at court hearings. And in 1949, the Swedish government also passed the right of the press to government information. So this meant that the press and the public had access to public records. This is great. If you're a journalist, you are working on a lead, you can go down to the city hall, pull some files on the person that you're interested in, and they'll make you a copy. But once you combine this with computers, private entities would gain the ability to gain vast amounts of information about its citizens with very little effort. So in 1973, Sweden got the Swedish Data Act. This was the first national data protection act. It had 3 tenets. 1, you had the right to get data about yourself. 2, you had the right to compensation if the data was incorrect. They were really concerned about data being wrong. And 3, it criminalized data intrusion. This is formally criminalized, and this law meant it was specifically focused on breaking into the offices where the data was stored. Kind of like this. The Swedes were smart, but they couldn't actually predict that the internet was going to be a thing. So back in Germany, the Hessian law was enacted, and other states were trying to work on similar laws. And based on Sweden, they determined that they needed a national law as well. So in 1977, the German Federal Data Protection Act was passed. And it had 3 parts. It ensured against the misuse of data. It prevented harm to personal interests, and it prohibits the processing of data without being specifically permitted. So it actually created a regulating body that gave out permits for people to do data processing. You can't just collect it and then decide what you want to do with it later. You have to go and get approval every time. Over in the UK, people kind of wanted similar laws. And after much reluctance and dragging of feet, the UK government eventually passed the UK Data Protection Act. We kind of think of the UK as sort of being a nanny state. They didn't really want to pass this law. In fact, one early commission actually found that there was no evidence to suggest that fears about the improper use of computers in the public sector are justified by current practice. They're like, yeah, data protection is not a problem. So this law was widely criticized, wasn't very effective. But in 1985, the UK joined the European Communities, which is a precursor to the European Union. And the European Union was working on its own policies. Like, look how optimistic that flag looks. In 1995, they passed the EU Data Protection Directive. And generally, this laid out a baseline respect for privacy, right? More specifically, it had 7 key recommendations. First is notice. You should tell data subjects when their data is being collected. 2, the data should only be used for the purposes stated and not for anything else. 3, data should not be disclosed without the data subject's consent. 4, the collected data should be held securely and from any potential abuses. 5, data subjects should be informed as to who is collecting their data. They should have the right to access the data and make corrections to it if they want to. And they should have a method available to them to hold the people collecting their data responsible in case anything else goes wrong in the previous principles. So this was really awesome, except it's a directive, which means that it's non-binding. It's just a suggestion or a recommendation, and it's not actually law. So no one really did anything at all. All right, so we're like in the late 90s right now. Do you notice anyone missing from this story? How about this country? Can anyone name the major national data protection law that we have here in the US? I gave this talk once before, and someone shouted out, the Patriot Act. And I know we have some Canadians in the audience, so the Patriot Act is this authorization of massive wiretapping and metadata gathering program by the US government. So it's pretty much the exact opposite of a national data protection law. You might say the Fourth Amendment. Fourth Amendment protects us from unreasonable search and seizure. And in fact, the closest we've become to challenging the Patriot Act is in Clayman versus Obama, where a district court ruled that it probably violated the Fourth Amendment. However, in ALCU versus Clapper, it was determined that the global telephone data gathering system is needed to prevent potential terrorist attacks. It can only work if everyone's data is included, and that Congress legally set up this program and that it does not violate anyone's constitutional rights. So even wiretapping every single US citizen doesn't constitute unreasonable search and seizure. So yeah, we don't really have a national data protection law. But we do have the Video Rental Protection Act of 1988. This prevents the wrongful disclosure of videotape rental or sale records. I'm sure you're all really concerned about this. So that's cool. And so don't get me wrong, we actually have a whole lot of laws like this. So all of these address like a very specific small part of data protection. Like HIPAA, you've probably heard of, it's just for health records. Fair credit reporting, it just allows you to update and make changes to your credit report history. CAN-SPAM is just about the collection of email addresses. So these are all like tiny steps in the right direction, very tiny steps. But more recently, we took a big step in the wrong direction. Somebody signed this into law, Senate Joint Resolution 34, and what it did was this. It basically reversed the law that prevented ISPs from selling your browsing history. So this is now legal, and you might say, everything is terrible here. I'm moving to Sweden, right? So yeah, maybe that's true if you live in the US. But if you live in the EU, you just got the EU General Data Protection Regulation, or GDPR for short. The scope of this is incredibly broad. It applies if the data controller, data processor, or data subject is based in the EU. So if you're an American company and you have one customer in the EU, you have to comply with this. It's a single set of rules shared amongst all the member states in the EU, and it has a couple kind of key points. The most well-known is probably the right of erasure, or the right to be forgotten. This means that you can go and get your company to delete your data. There's also the right of access, get a copy of your data. So this leads to really fun and interesting things where reporters go and call up Tinder and they get their mind blown when they find out that tech companies are actually storing every single piece of information about you. This journalist asks, like, what if my data is hacked or sold? And so yeah, what if it is hacked or sold? So the law carves out space for data breaches. A data breach has to be reported within 72 hours. 72 hours. Not 5 weeks. Not 1 year. 72 hours. It also outlines the right to compensation. So if there has been a breach, the person that has suffered the damage has the right to receive compensation. And this is actually amazing for the EU because in the EU, they don't have anything like a class action lawsuit like we have here in the US. So this is actually a way for consumers to get monetary value from companies. Also, pseudonymization. The resulting data cannot be attributed to a specific person. So this is basically use encryption on your data, please. And consent. Data collectors must be explicit about what is being gathered and what it's being used for. It also sets up a person at every company called the Data Protection Officer. This person has expert knowledge of data protection law, and they work with the commissioners to figure out if their company is in compliance or not. And the best part about the GDPR is that it is binding. There is a warning in the first cases for non-intentional non-compliance. There's also regular audits, And then there's also fines. So the upper fine is as much as 20 million euros, or 4% of annual worldwide revenue, whichever is greater for the first offense. So put that in scale, Apple made $229 billion last year. A single fine would be $9 billion for them. That's huge. And this went into law May 25th, 2018. All right, so the last time I gave this talk, it hadn't gone into effect yet, so I made some predictions, and I thought it'd be interesting to revisit those. So the first prediction I made was that GDPR compliance is going to be a big deal. And yeah, it's a big deal. You can kind of tell how big of a deal something is, how much a moneymaker it is, by how many ads show up when you search for it. Second prediction I made was that someone is going to get sanctioned. So like, what good is a law that you don't actually enforce, right? And that's exactly what happened. So in October of last year, a small business, this was the first time GDPR was enacted, small business had a camera set up outside their business, and it was recording too much of the sidewalk. And so they got fined under the GDPR. This was in Austria, because they weren't asking consent for the people that were being recorded. In November, there was a German chat site. It reported a data breach to the local protection agency. They investigated, and they found out that they had been storing their user passwords in plain text. They were fined 20,000 euros for data storage practices, not because of the breach, right? They did everything right. You don't get fined for having a breach, or as long as you report it correctly. This was the next one. A Portuguese hospital got fined 400,000 euros because they were using bogus accounts to access patient records. This is great. And most recently, this little software company that you might not have heard of, they got fined 50 million euros for not sufficiently informing users whether advertising data was being collected and how it was personalized. So I was a little more correct on that than I probably would have liked to have been. The third thing I predicted was that don't expect anything to get better in the US in like the next 2 years or so. And I said that you probably should expect further dismantling of privacy laws and regulation. I was totally wrong here. So recently in California, the great nation of California, they passed the California, the California Consumer Protection Act. And so this is for any for-profit entity that does business in California, makes more than $25 million, and either processes the data of a lot of people, earns its money from processing data, or has a bunch of data about its users. They can be fined for data breaches, for intentional violations of this. And this is great. This is going to go to law in 2020, January 1st, 2020. And even more recently, there were some bills introduced to the Senate to introduce federal data protection laws. So this is one of 2 bills currently referred to the Senate Committee on Commerce, Science, and Transportation. And yeah, we're actually kind of working on creating a national law. So yeah, maybe everything is not so terrible after all. All right, one last thing. We live in an age where we have the ability to generate so much data about ourselves, and the capacity for others to collect it is enormous. So it might not come as a surprise to anyone in this room that Tinder has so much data on its users, for example. But for the majority of Tinder users, they simply don't know, or they may not realize this. We need to make sure that on their behalf, and for our own sake, that this data is being protected, it's being used responsibly, and that it will not and cannot endanger the people from which it is taken. Thanks.
too demanding or too greedy, your mind is not rich and self-sufficient. When your mind becomes demanding, when you long for something, you will end up violating your own precepts, not to tell lies, not to steal, not to kill, not to be immoral, and so forth. If you keep your original mind, precepts will keep themselves. The beginner's mind is the mind of compassion. When our mind is compassionate, it is boundless. This is also the real secret of the arts. Always be a beginner. Be very, very careful about this point. too demanding or too greedy, your mind is not rich and self-sufficient. When your mind becomes demanding, when you long for something, you will end up violating your own precepts, not to tell lies, not to steal, not to kill, not to be immoral, and so forth. If you keep your original
Welcome back.
mind-
We're going to have our next talk by Yeli, who's going to be doing a talk on gender dictionaries.
Hello? Okay. Hi, I'm Yeli. Well, I want to say that I'm not a Python developer, but before I get into all the technical stuff, I wanted to play a little word game, and it's simple. You don't have to do anything but think really hard. So the game is I say a word, and you think of an image that's associated with it. Cool? Okay. Superhero. Ninja. Hacker. Rockstar. And then now I want you to consider if the images that came up, whether they were of a man or a woman or somebody who doesn't exist in those binaries, and this isn't to shame anybody, it's just an opportunity to reflect on biases, because those biases that we have, they make their way into things that are supposed to be objective. So when given the option, i.e. translating from English to French, machine-assisted language translation systems like Google Translate code the word nurse as feminine. So in the Turkish language, there is a gender-neutral pronoun o that means that can cover he, she, it. So when Google Translate has to translate a sentence from Turkish to English, then it has to determine what o represents. So this is a poem that was written by Google Translate on the topic of gender. It's a result of translating words from Turkish to English. So some of the lines are, he's a soldier, she's a teacher, he's a doctor, she's a nurse, he's a president, he's an entrepreneur, he's an engineer, he's an architect, he's an accountant, he's a lawyer. He's a belly dancer, it's like, okay. But he's a hairdresser. There are a couple that surprised me, but I think most of them are like, oh, okay, that makes sense, I guess. So the algorithm is basing its translations on a huge corpus of human language. So it's reflecting a gender bias that already exists. So another example of the effect of gender in language is the augmented writing platform Textio they help you write job listings, I think. So they saw that gendered language predicts who you hire, so the amount of feminine or masculine words actually affects who applies for your job. So I was thinking about this in other ways, that gendered language communicates ideas we might not mean to. So I wanted to create something that allows us to explore gendered language, and that's what this talk is about, building a gendered dictionary. So specifically, I wanted to make an API and a tool that you could find all the gendered words, you could find the equivalent to a gendered word. And to be clear what gendered words are, they're like words like prince and princess, father, mother, actor, Prince Charming. So some of them have equivalents, like lady has gentleman, gentleman has lady. Some of them don't. Some of them, like actor, may not be gendered in practice, but might be gendered in definition, or they may be not gendered in practice, gendered in definition. So the first question I had to ask was, where do I get this data? So I found some existing data sets of gendered words. So a team of researchers from Boston University and Microsoft Research created like a small subset of gendered words because they were trying to debias word embeddings. So like the data that Google Translate is trained on, they wanted to debias that data, so they came up with a subset of gendered words, but most of the data sets weren't substantial enough. They were like under 1,000 words, and there were a lot of false positives in there. So I decided I would get the data through APIs, static data sets, and web scraping. So before I started coding anything, I had to think of my criteria. So what would I tell the computer a gendered word was? So it was all the words in the dictionary that have at least one of these terms in their definition. So businessman has the word man, archerist has the word female, so these two would be gendered words. Then I started looking for some APIs. One of the first I found was Wordnik, which is the largest online dictionary by number of words. So it has a free API and a feature called a reverse dictionary. So a reverse dictionary means find all the words that have one of these terms in their definition. So this is the reverse dictionary for the word woman. So all those words you can see all those words that are listed below have the word woman in their definition. So I could find all the gendered words, theoretically, by asking the API for the reverse dictionary of women and all those terms that I mentioned before. So WordNik has a client for interacting with the API, so I just make a call to the reverse dictionary in line 7, and then I add the words to an array. So if you go to the website, it will show you like 3,000 words, but I only got like 400 back, which I guess makes sense. So I found out that the API doesn't actually make all the words available to use, so I had to start looking for other methods to find the data, and then the other method was static data sets. So I looked on GitHub, I found this dictionary that has a bunch of words from like 2004, I think. So I used the JSON module, I loaded that in, and back to like what a gendered word means. If it has one of these in a definition, then it's a gendered word. So like I was really just like kind of learning Python, and then, like this was the first thing I wrote, which is a pretty long like if statement. So I decided instead of doing that and like making a file with like 300 lines of code, I would use regex. So for example, my name's Miley, but a lot of people misspell it. So like I can make one regex pattern to fit all of the misspellings and my actual name. So I decided to make a regex pattern for all of these words, and it looks something like this. If you're not familiar with regex, the pipe symbol represents or, so it's saying woman or female or girl or girls or woman, blah, 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 yeah. And then, yeah, if one of these terms is in the string, so I do a search with the RE module in Python to see if the word is in the string. But the issue with that is that it gets words like this, and like these are not gendered words. Like management is not a gendered word. Boy with a $sign is not a gendered word. Like manatee. So I was like, okay, this isn't working. So introduce word boundaries. So you add word boundaries, and it only gets full words. So not management and Boyle's law. But then I also, I wanted grandfather because grandfather is a gendered word. But since it's only looking for whole words, then it wasn't actually going to get a grandfather. So now I use word characters. So now it's getting father and grandfather and grand-father. So step by step. The parentheses mean this is all in a group. So grouping the pattern together is one. Character set means match any character in the set, the square brackets. Like I said, /W is the word character. Then this is saying match a dash. So the asterisk is saying match 0 or more of whatever comes before. So it can be 0, it can be 1, it can be 4. So you can have gfather, you can have grandfather, you can have g.father. And this is saying it's optional. So these are the final regex patterns. They're pretty long. But after I finalized the pattern, so I went through the dictionary, the Webster dictionary I got from GitHub, and then if the definition contained one of these terms, so I did a search in line 7. So if it contained one of these terms, then I added it to the list of gendered words. So when I added the words together, I came up to about 8,000 words, and I was like, okay, this is cool. This is more than the 400 that I started with. But then I went through the list and I saw lioness was in there, and lioness, for the dictionary, lioness is a word that describes an animal, so it's not actually a gendered word that I want. And there were some other words in there that I was like, this is not a gendered word, so how do I get this out? So I decided I would find patterns of the incorrect words, so I could figure out a way to remove them. And one of the patterns was that in some incorrect words, the gender term was being used as the object of a preposition. So for example, in the definition of waterfall, it's an arrangement of a woman's back hair. It's not a word that describes a woman. In the definition, the word woman is the object of a preposition. And you can see the same for Peter and Mantlet, stable sand. Peter is a common baptismal name for a man. It's not a word that describes a man. It's a thing for a man. So how would I remove words in those categories? So first, I had to isolate the string. So I only care about everything before and the gendered word. So I don't know if you can see the highlight, but everything that's highlighted. The rest of it, I don't really care about it. So to get the part of the string before the gendered word, I would have to find the gendered word and then strip it at that location. So using the regex module, I found the location of the word man in that string that's in line 8. So in line 4, I do a search, then I return the position, and then we get the end index from the position in line 9, and then we use that end index to strip the string right where the gendered word is. So you can see it's trimmed to a common baptismal name for a man. We don't have the rest of the definition. After we trim it, we can remove any punctuation using the string.punctuation in line 5. So I just imported the string module, and then that comes with it. So if it had punctuations in line 7, then the new definition would not have any punctuations. The next step was NLTK, which stands for Natural Language Toolkit, and it's used for processing the English language. So the first thing we do is tokenize the string, which means we strip it up into different parts. So that site below is like an interactive demo of tokenization. So I pass in the string, and then it breaks it up into little parts. And then it also throws away the punctuation if you haven't done that already. So after we tokenize, then we can use a part of speech tagger to add parts of speech to the different tokens. So in line 5, it's tokenized, so it breaks up the string into an array of different parts. And then in line 8, we call NLTK, we call the POS tagger, and that gives the different tokens in the array a part of speech. And like, I don't know off the top of my head what these means, but like you can find them online. So JJ means adjective, so we can see baptismal as an adjective. NN means noun, so we can see man as a noun. 4 is IN, which is a preposition or a subordinating conjunction. So we can see what parts of speech are the different words in the sentence. So after we do that, then we check. So if you remember, we cut the string right when we saw the gender term. So we know the gender term is the last item in the string. So we check the item before the last item, which is what we're doing in line 7, and we say if this is a preposition, then return false, it's not a gendered word. So after I did that, there were some other patterns I saw. One of them were clothing items. So like these are some of the gendered words that were in the dictionary, like skivvies and hobble skirt and pajama. So I found a list of clothing items online from the Collins Dictionary. I applied for an API key. I still haven't, like 6 months ago. I still haven't gotten it. So I was like, oh, I'm not gonna wait for you to give me this list. So I decided I would scrape their website. So web scraping is a tool for extracting information from websites that involves grabbing the HTML that makes up the website. So in Python, 2 libraries that I use for web scraping are urllib.request and Beautiful Soup. So the first thing I had to do was look at how the data I wanted is structured in the DOM. So I can see that the data that I want is the child of a span, is a link that's a child of the span that has a class TD. So I load in the URL using urllib in line 3. And then in line 4, that's all the HTML called soup. And then in line 5, I find links that are the children of spans with the class TD. And then I get all the text, and then I have the data that they didn't want me to have. So after I filtered words that were secretly clothing items, gendered words that were secretly like animals, I came down to a list of about 4,000 words. And then the last step, or one of the last things I needed to do was find gender opposites. So for each word that had an opposite, I wanted to find what that opposite was. So we can do that using Word2Vec. Yeah. So Word2Vec is an algorithm that transforms word to vectors. So back in 2013, some researchers at Google set loose a neural net on a corpus of about 3 million words from Google News texts. And the neural net, the goal of the neural net was to look for patterns in the way words appear next to each other. So you can see the words in green, garden appears next to hose, and it's far away from refrigerator. Refrigerator appears close to microwave. So the Google team discovered that it could represent these patterns between words in vector space, and you could analyze these patterns using like simple vector algebra. So words with similar meanings occupied similar parts of the vector space. So it's based on the idea that a word is characterized by the company it keeps. So a word is close to a word in vector space if they appear in the same context. So for example, if we gave the algorithm this text, it would say salt is more conceptually close to seasoning than it is to say chair, because they are used in different contexts, while salt and seasoning are used in close contexts, and then seasoning and chair are not really used in the same context. So with that model, we can do stuff like getting the similarity of words. So what similarity of woman and rectangle is under 0.1. The similarity of woman and wife is about 0.8, I think. And then you can also do word analogy. So woman is to queen, as man is to king. So in Python, if you want to use models and the word2vec algorithm, you can use a library called GenSim. So like I mentioned earlier, the Google researchers trained a neural net on about 3 million words. So we can load in that model actually, like we're doing in line 2. It's called the Google Vectors. You can just Google that, like Google Vectors. And then if you want to do the analogies, you use the most similar method. So that's what we're doing in line 9, and the way you phrase it like you would an analogy. So woman is to wife, as man is to what? So the positive words are woman and wife, and then the negative would be man, and then we get the result from the model, and then if the score is above 0.6, then we say, okay, this is an equivalent. So that was it. I got the initial word set from APIs and static data sets, then I cleaned and filtered the data set using regex, web scraping, and NLTK. Then I used word2vec to find the equivalents for the words that have them. Then I created an API to house the data. So you can see woman is to wife as man is to husband. So when navigating the site, users can learn which words or named phenomena are specific to one gender, i.e., so which words don't have gender equivalents, or where there are significant imbalances in the English dictionary. So what gendered experiences do we have names for? What might be missing? What words for describing a certain gender exist in surplus or in scarcity? So what words have undergone semantic derogation, which is the process where words after time take on more negative connotations, like mistress and master were originally supposed to be the same word, but over time one has taken on a negative connotation and the other has stayed the same. So in summary, the words we do and don't have matter, so they reflect the biases that we embrace and the ideas that we value. So we risk enforcing and I can't say that word. We risk reinforcing these biases and negative values if we don't interrogate the words we use and why. And that's all. Thank you.
funky, funky, funky.
Oh, summer. It sounds good right now after what we just experienced, doesn't it? Grilling out, lawns being mowed, and pools opening. These are some of the things we expect with summer.
So I'm Andy Fundinger. I've been a Python developer since Python 2.4. The first Python books I got said Python 2.2, newly revised for Python 2.3, and they had a few pages in the back that said when Python 2.4 gets here, this is what you're going to get. And all the exciting things that were coming in Python 2.4, which was what I was running. Everything we're doing today is Python 3 with some notes about when we actually got them. I work for Bloomberg. Bloomberg sells financial data and analysis. We have about 5,000 developers. We have over 5,000 developers, 2,000 of them focused on Python, mostly in New York, London, some in San Francisco, and smaller offices throughout the world. This talk is about decorators. And it's about the fact that when we go to talk about decorators, it's hard to get them into categories, and we historically have not done that. The idea is with a common terminology, we can start to discuss more easily our decorators and our uses and the problems there in sort of like design patterns. I feel it's a little bit different. This talk is targeted at intermediate developers. People who can write decorators, but maybe aren't sure when or why you might want to do that. And architects who might want to work across teams to implement or manage their design. We're going to do a brief review of decorator syntax and implementation, but this is not intended to teach how to write decorators, just to review it, so if you haven't seen it recently or haven't thought about it, you're fresh on it for the rest of the talk. Just a note, of course, like anything, any decorator can be replaced by taking the code that's in the decorator and pasting it enough places throughout your application. Decorators are all about taking this code and allowing it to be reused and factored out of the functions that are being decorated. Generally, the decorators are inserting a section of code which is of flat-out arbitrary complexity into a single line, and that outline is actually above the function, above the def, so you're not even seeing it if you read the code casually. Your debugger is often skipping over it, and so are your eyes, for better or for worse. The decorators started in Python 2.2, and they started with static method, class method, and property. We used to write them like this. And this is still all they're really doing. But in 2.4, the @ sign was added as syntactic sugar that we tend to know today that does exactly the same thing. We can, of course, write our own. All it is a function that takes a function and returns presumably some sort of callable. Here's one that takes whatever function it's decorating and returns a function that always returns none. By Python 2.6, we could decorate classes. So we can take that nullet decorator and decorate this class. And now anytime you try to construct an instance of this class, you get none. Maybe not something you would want to do, but syntactically it's allowed. Where we usually start having some trouble on our implementations around decorators is when we want to use decorators with arguments. So we'll take a quick look at that. Here's a decorator with an argument. The trick to this is that it's not doing anything at all. All Python is saying is, oh, I see a function here. I'm going to run it. And I'm going to expect that that returns a decorator. And I'm going to expect that that decorator will then take a function. And that function will wrap in exactly the way as any other decorator. So here's one of those. Mult_arg takes an argument of some number to multiply by. It returns the actual decorator, which takes an actual function. That function returns a wrapper that calls the function that it's given, multiplying by mult, and off it all goes. As an example, we've decorated print x with mult_arg3. Normally, print x would just print x. If we do print x1, having decorated it, we get 3. If we do print x of hello, we get hello, 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 because after all, we can multiply strings. Notice this is two closures, one for the argument, mult, and another one for the function, func. Normally, for some reason, which I personally am not quite sure I understand, we do tend to write our decorators as closures. There's not a particular benefit to this. We can write them as classes. It just has to return a callable. So here's an example of doing that. Class traceIt captures the function in init, stores it in a class, in an instance variable, and then call. When it's called, calls that function. So we decorate traceIt around this rand function, and then when we call it, we print out the arguments that were called, and off we go. Okay. Enough of that. Let's move on to the actual taxonomy. We'll start with A because I put these in alphabetical order. The argument-changing decorators are decorators that add or remove an argument when the function is called, or maybe they just change the value or type of an argument at call time. The problem is, if you go look at the code that you have decorated and then go, I'm going to call that, it won't work. If you're trying to call it for a test, you're going to have to do something to set up the decorator so that the code can actually be called. So we'll take an example of this, as we will for each of these. The click library is a wonderful library. We use it quite a bit. Click command and click option, you put them together. And what this will do is cause click to go to sysargv and get --n from the command line and pass that in to your function. The signature of the function has now changed to pass no arguments. Click will get them for you. If you try to pass the argument, it will not work. We can write our own. Here's one. Most functions do not know what their own name is. It would take some stack manipulation to figure that out, or we can have a decorator that does that. So here's a function with name decorator. The wrapper says, okay, I'm going to take the function name and I'm going to make it the first argument to the function. Why? I don't know. So we'll decorate this self-aware function with it. Doesn't do much. It just prints its name and the other argument that's given. You would think that you call this with 2 arguments, but when we actually call self-aware here with 1 argument, it prints out self-aware here, and that's the right way to call it. There's a variation of this which bothers me a lot because it messes up my alphabetical order. But other than that, it's great. The return value decorators run the function perfectly normally, but only mess with the output. So I pulled an example from TurboGears. They have one add expose, which will take a parameter JSON and say whatever this thing returns, make it the JSON version. And here it is. It's relatively simple. Pass back a dictionary, and TurboGears will take care of that for you. They only alter the output, so it's a little bit less problems with that, but still some. Again, we can write our own. I decided to mess with function name again. This is a composable result decorator. It takes whatever's returned and turns it into a dictionary keyed by the name of the function. So if we take process 1 and process 2 and decorate them both with composable result, then we can take those results and update them both into a dictionary, and we'll get a combined dictionary that has all the results. So let's move on to something completely different. Here's a binding decorator. The binding decorators implement the descriptor protocol, and they change how binding works in Python, which is itself very, very fun. The standard library provides our best examples of this with static method, class method, and property, but they aren't the only ones. The problems here are we're kind of used to our methods working the way they work, and this just changed that. So we get a new language pattern that maybe just came in from another language, something like lazy execution, something that's not how I thought my function was going to work. We might get a new exception that we didn't think could happen or happened at a different time. Here's one. SQL Alchemy has a thing called a hybrid property. It runs a different set of code on the instance and the class. So on the instance here for radius, it just does the math and calculates the radius. On the class, it generates a SQL statement so that it can be used in a query. Again, we can write our own. Let's disable a feature in Python. Normally, we can do things with our instance methods. We're used to how those work. If we want, we can get the unbound one, but let's make true instance methods in Python. We'll not have any of this getting at the class version of that. So this is an instance method decorator. It's a descriptor. And if you try to get it from the class, we'll have none of that. So here's good class. It's a good class. We'll have two methods. They're exactly the same except for this decorator. Simple method, which is decorated, and normal method that's not. If we call them on instances, they both work exactly the same. Normally, we can get the unbound version of this function, and it's just a function in Python 3 or an unbound method in Python 2. However, if we want to go and get the simple one, we have disallowed that. It is now a type error. That might, in a very limited case, be useful just like that, but in a more stretched case, you get into something like SQL Alchemy, where you are saying this is a behavior. Another, if not the most common kind of decorators are our control flow decorators. Our control flow decorators control whether a function will be called and how many times. The problem is now you wrote code to call a function, and you don't even know if that function got called. So you might write code that says, I don't know, hits PayPal and sends some money, and maybe it gets called 2 or 3 times, you know, just because the decorator did that. This is one that you probably try and retry a few times. If you haven't tried it yet, I suggest you retry it again. Retry. Great little decorator. Straight from their documentation, throw it on something that occasionally breaks, and it'll try it again. If you do go to use this, they have a whole lot of options. You can have it do like exponential back off, try it a maximum number of this times only if you have these exceptions. Probably doing it exactly like this is not ideal for your case. Of course, we can write our own. This one's even worse because it does it infinitely. But it exposes, you know, exactly the sort of thing you're looking at. We'll have an infinite retry while true, as long as we get a runtime error. Just go ahead and run that function again. And here's a function, anytime it comes up with a negative number. Yeah, sure. Just call it again until we get a positive number. That's a great way to get a positive number from 1 to 10. The descriptive decorators are actually the ones that caused this talk to come into being because someone told me they didn't exist. They told me that all decorators changed the data going through them, and I said, well, what about the descriptive decorators? They either add the decorated object to some sort of collection, or maybe change some metadata property on the function for the purpose of documentation, patching, plugins. The problem is they did something, but they changed nothing. So it's unclear how the dispatching is going to be done, and if it didn't work, it's unclear what didn't work because you put the decorator there, and if you decide you want to tweak that registration, the decorator didn't give you a clear idea from that point. You just put the decorator there. PyTest Marks says this. Look, I marked it as a web test. It's now a web test. If I run pytest-m web test, it marks everything running as a web test. It collects all 4 tests, but there's only 1 dot there because it only found 1 that's a web test, and it ran that. It's good. I recommend using these marks if you haven't tried them, but the mechanism behind it, as long as when it doesn't work, is unclear. There's another one, which you may use a lot. Routing via decorators. When you add a Flask route, you add a app route decorator, and it takes your function and adds it to a routing table. Doesn't change your function. If you ever write unit tests that hit this function directly, you know you can call it. It's the same function as it ever was, but a whole different set of machinery is now plugged into this function. This is the example I wrote in that discussion about how these didn't exist. This is a QA list decorator, made very quickly to show the point, but here's a global list of things that need to be QA'd. You'll notice the decorator here is returning exactly the function it was given, but it grabbed the name of the function and put it on the list. So the new code and the refactored code has been marked. It needs to be QA'd before release. The well-trusted code, we're good. And if we look at it, our list has been maintained. Somebody please take this mechanism and make a library out of it. I want to use it. Here's one. I'd like to know, as I go through this, how many people have actually encountered these in the wild before I show the open source example. The execution decorator reads your method or class or your code, which it may then reinterpret the source code to basically not be Python. The problems here are just plain infinite because you just changed the source code to not be Python anymore. This truly means the code you've wrote is changed by the decorator to some other code that is then executed. So it might just be analyzed for dependencies. It might have objects in the AST swapped out, injected, or removed. It might be recompiled by different rules. Number does this. Number.jit. This is right from their documentation, as the open source examples have been. You throw this on a function, and if you follow the rules of number, the function is faster. If you didn't follow the rules of number, it will crash. I'm not sure whether that's a runtime crash or a compile time crash, but it will crash. We can write our own of this. I don't recommend it, ever. But here's one. We'll take the function. We'll grab the source code. We'll chop it into lines. We don't need line 0 because that's at replacer. We need line 1. That's the name of the function. We'll take the rest of the lines. We'll run a basic search and replace on that. Then we'll exec it. And we'll take the globals. We'll pull that same function name out of the globals, and that's a new function that we made. Gosh, it's good. All we have to do is return a function. So here's our sample function. If we run it normally with 1 and 4, we get 10. But if we replace B with B star B and run it, we get 26. If we replace A with A star 3 and run it, we get 14, but we also turn sample into SA star 3 MPLE. In the not recommended case you ever write one of these, there are other tools available, like manipulating the bytecode or the AST. Still to be avoided, but. Now there's another category way down the end, and I have problems with these two. These are the wrapping decorators. Supposedly these do nothing. They just run some code around the function call, and they don't even count as a descriptive decorator. They don't affect the function at all, and I think they should generally be replaced with context managers. They do so little that my greatest fear is that they throw an exception and then they become a control flow decorator you didn't expect. They also force your code, once you've decided you're going to use this, you wind up forcing your code to have a function here just so I can use the decorator that I wrote. But I have found one of them that does seem to fit very logically. I can see why the time call decorator is probably good to be a decorator, and I can see why it shouldn't be changing anything from the profile hooks library. So they do exist, and obviously I don't feel compelled to show how to write one because you just don't do anything. So they do exist, and I can name them. So in conclusion, here's the 5 main kinds that I've named so far, plus return value and wrapping. And here's some other examples beyond the ones on the slide. Argument changing, we have parameterized from PyTest also. Flask templated has a argument changing decorator. Binding, there's a new library called Variance. It's kind of fun. Does some tricks with binding. Pyramid also does one. Control flow, LRU cache in the standard library, or anything doing memoization. The inline callbacks from Twisted is good. The descriptive decorator, there's a set as test in NumPy. Cython obviously has something very similar to Numba, though you do have to already be running Cython rather than Python there. There's also a few that I'm looking at. I'm just not sure whether they're common enough to be worth naming. You can take two of these and make them in the same decorator. I would call that a hybrid decorator, but I'm not sure anybody cares. There's an old pattern from Python 2 where you could use the add-apply function, and you could write some code that only runs once and then becomes a constant value on the class. I'm not sure I can find places where we're doing that significantly anymore. You could write it still. Again, I'm not sure that's worth naming. And I'm very much looking for others or for things that don't fit into these, or for anything that you feel these need to be divided or renamed or added to. So I'd like to hear very much about those through the rest of the conference. Thank you very much.
Hey everybody. So our next talk is going to be a little different. So we're really, really happy to have this speaker join us today because they were meant to be here in person with us. Unfortunately, due to circumstances outside of our control, they were unable to be here physically. So over the last month, we've been pulling together a plan for them to present remotely. So I'm really, really happy to introduce you all to Chirag Shah, who's presenting to us from India today. So everyone cross your fingers and hope that the internet gods shine upon us and that everything goes smoothly from this point on. And I'm going to turn it over to Chirag now. Thank you.
Hello, Python stars. Is my screen visible? I hope you are having an amazing time at PyCascades this year. Well, it's unfortunate I cannot be present in person out there, but now I'm here and I don't want to waste any more time. My topic for today's talk is understanding multithreading by deciphering the CPython interpreter source code. So I'm going to walk you through a short journey of CPython architecture and a little bit Pythonic code. I'll be running quickly as I have a limited amount of time. You can find me on Twitter, LinkedIn, and GitHub. So before digging directly into multithreading, I would like to talk or I would like to go through some basic operating systems concepts. So yeah, here I begin. So processes are instances of program and they run in separate memory spaces. Threads are entitled within these processes and that are scheduled for execution. They share the memory. Multithreading, it's self-explanatory. It allows executing multiple threads concurrently. Multiprocessing, it adds more processors. So the diagram on the left indicates multiprocessing, and on the right, it indicates multithreading. Multitasking is running more than one program at a time. So there are two different types of multitasking. The first one is cooperative, and the next one is preemptive. So preemptive multitasking, it uses an interrupt mechanism. So it suspends the current executing process, thereby invoking a scheduler, which in turn determines which process should be executed next. Cooperative multitasking, it doesn't involve any kind of context switching. The processes voluntarily yield the control, enter between themselves. Okay, so I'll like to illustrate this with the help of swing analogy. So during our childhood, most of the times we used to swing in the garden. Some of us would like to give away the swing after swinging to all our friends, while most of us were reluctant to give, so the swings had to be snatched away from us by our parents. So cooperative multitasking is when children give away the swing voluntarily, and preemptive is the one where swings are taken away. Parallelism and concurrency. So these two terms have a lot of similarity in the dictionary definition, but in terms of computer science, they vary a lot. So concurrency is when two tasks are being performed at the same point of time. Parallelism requires that at least two or more tasks are being actively performed at any particular moment of time. So let's understand this with the help of a simple fast food chain example. So we have shop A on the left and shop B on the right. Both the shops have two common collect counters. One is the order and another one is the collection. So in shop A, only a single person shuffles between both the counters and handles its customers. Whereas in shop B, there are two different separate people aligned at any point of time to handle its customers. So shop A utilizes concurrency, whereas B utilizes parallelism. Speaking about IO-bound processes and CPU-bound processes, IO deals with a lot of IO-based activities. It involves typically reads, writes. CPU-bound process, it spends most of the time doing churning numeric data, doing calculations, and IO-bound process always have greater priority as compared to CPU-bound process. Okay, so that was a quick overview of operating systems. Now delving deep into the Python threads. Python threads are plain POSIX threads or system threads which are managed by operating systems. The Python interpreter is a virtual machine and it has no intelligence of thread management. They simply call the run method of thread. Whenever a thread is created, there are three different things that happen behind the hood. First one is a data structure is created that has an interpreter state. This is called as PyThread state. a new pthread is launched, PyVal call object is called. So this PyVal call object is a function in the interpreter which runs some Python callable. Now let's understand, or let's see how a PyThread state looks under the CPython interpreter source code. So here's it. It contains counters, thread IDs, stack frames, recursion web, profiling, and tracing details. Why PyThread state is important is because interpreter has to be aware about which thread it is dealing with at any point of time. Okay, so a very simple example of counting, and I have like 100 million out there and I'm counting in reverse order. The time it takes to count this is approximately 54 seconds. So the natural second thought would be to use parallelism and reduce the timing. Let's do that. Okay, so now we have a couple of threads out there, each counting 50 million each in reverse order. And to everyone's surprise out here, it approximately takes about double the time as it took for the serialized code. This is the point where I realized when multi-threading in theory looks very simple, whereas in actual it is a lot worse. And in terms of Python, it even gets worse. So at this point, I had to like dig in and realize and understand the unusual behavior of my parallel code. And that's when I started understanding about the global interpreter lock in Python. Oh yeah, and as promised, this beautiful image is taken from Nina's talk on memory management at North Bay Python. I have attached the link of the talk in references. Do watch, it's amazing. So before like going deep into what and how of global interpreter lock, let's understand why a global interpreter lock is needed beforehand. So in Python, everything is a Py object. When I say everything, I literally mean not just the list, tuples, dictionaries, sets. I also mean type objects, integers, strings, floats, etc. It also has stack frames. So this Py object is basically the fundamental structure in Python interpreter. It has three members. The first one is head extra, the second one is obref count, and the third one is op type. Head extra is a macro, as you can see, it does not have a semicolon, and under normal condition, it just evaporates to null. Obref count is a reference count, which we'll be speaking about in the upcoming slides. Py size t is just a kind of signed relatively big integer out there. Okay, so let's talk about op type. So op type, it defines the type of object, and the type of op type is struct type object. This struct type object is type def in something called as PyType object. So let's see how a PyType object looks in Python. That's the overall structure of PyType object. It roughly has around 50 members. Function pointers that implement things like dialog, wrapper, hash, get attributes, set attributes, data, and so these are the core things which are being covered in PyType objects. Coming back to global interpreter lock and reference counting, so reference counting is nothing but number of times a Python object is being referred in the source code. So there are two macros out here, pyincref and pydecref. Basically, they evaluate to source. Basically, they evaluate to the pseudocode which is present in the right bottom, and that's pretty much how it's represented in CPython as such. I have heard about functions like xincref and xdecref as well, which are safer versions of incref and decref. So what they do is they basically do a null check before they increment or decrement anything. Okay, so let's move forward. Yeah, so this is just a simple reference counting example. What I've done is I've just used 300, and since 300 is being referred 4 times, so the reference count of 300 is 4. This image is again taken from Nina's talk on memory management. Okay. Speaking about reference counting, so we have a function called as getRefCount in the sys module, so which returns the reference count of any variable we pass to it. So this is a log scatter plot of getRefCount versus the actual integers. So I've used 1 to 1000. Those are the range of integers, and against it is the ref count. You can see a lot of scrambling of integers between the range of 100 to 300. Okay, so without GIL, when we have multiple threads trying to increment or decrement certain values assigned to a variable, they may fall under the problems of canonical race conditions. Now, in order to overcome the race conditions, if we try to implement multiple locks, we may again fall under the trap of deadlock. So it's really great to have a simple, fast, and easy to implement global interpreter lock without any deadlocks and overhead. talking about the dictionary definition of global interpreter lock, it is just a binary semaphore which which prevents multiple threads from executing the Python bytecode. Now, one golden rule I would like to remember, I would like to mention here is one thread always runs Python while n others always sleep and await IO. Now, in order to understand GIL, this is an abstract representation of global interpreter lock. We have n threads out here. The red one is the one which is currently being executed. There are n-1 threads that are just put on hold or they are awaiting IO. Okay, so there are certain functions in CPython source code itself. One is there are certain modules of gzip, there are certain modules of ctype and hashlib. They themselves release the GIL. The reason why they release the GIL is because they don't do anything Pythonic as such, or they don't do any Pythonic operations, and hence they perform a lot of algorithmic operations out there, and they do not require the GIL. That's enough of theoretical talks about how GIL is what it is. So now let's look how a GIL really looks in CPython. You can see this line called a static pythread type lock interpreter lock. So this single beautiful line is just the entire global interpreter lock. It is defined in the file called as ceval.c, and static provides a truly global mechanism. The pythread type lock, it basically evaporates just to a normal operating system lock, and you can see a function called as pyval init thread. So this is a function where your interpreter lock is not only initialized, but also it is being acquired by a thread. So let's move forward. So yeah, this is a simple canonical example of how cooperative multitasking works. Now what I've done here is I've just used two threads out there and I'm trying to call the connect function. What connect function does is it connects to python.org, and before it connects, I've used connecting as just I'm trying to log it, and after connecting it logs connected. Ideally though, in ideal scenarios, what should happen is your first thread should try to connect. After it is connected, the second thread should go and it should connect. But here the scenario is quite different. Both the threads try to connect at the same time and then they get connected. So let's see why we get such result. So there's this line number 7 that calls the connect function from the socket module. So that is a point where the GIL is dropped. Let's see how a connect function is represented inside CPython. So this is a function called as socket connect, which is the same connect function. It's represented in CPython, and what matters here are the two lines out there, py begin allow threads and py and allow threads. So these are basically the macros which are defined, and py begin allow threads is a macro which states that the global interpreter lock should be dropped, and py end allow threads is a macro which states it should be acquired back. Well, these functions, they lazily evaluate to something called as pyval save thread and pyval restore threads. So I've pulled out these functions from the actual documentation, which clearly state that they release the GIL and they acquire the GIL again. So that was about cooperative. Now let's talk about preemptive multitasking. So this is a simple example again I've used, and I've used 5 threads which try to call the run method. Basically the run method does nothing. It just loops over a couple of variables, and that's it. It does nothing yet. The very surprising thing, when I ran this program in Python 2.7 and when I ran it in Python 3.5, it literally produced a very different output compared in both the versions. So you'll get to know why the output varies on both the Python versions, but let's keep this aside for a moment and let's talk about something called as pyeval_eval premix. So what I'm going to represent is, it's called as a heart of Python or core of Python. So this is a function where each instruction bytecode is executed line by line. So what interests us are the function pythread release lock and pythread acquire lock. Now these functions have undergone a tremendous amount of change in Python 2.7 and Python 3.5. So what I'm representing on screen is Python 2.7. So this is acquire lock in 2.7. This is release lock in 2.7 again. So now let's see, this is acquire lock in 3.5, and you can see how the definition has changed. It ultimately gives call to something called as pyacquire lock time, and you can see the lock time, it's huge. It's huge out here, and so this is release lock out here in Python 3.5. So now let's see what has changed between 2.7 and 3.5 and why there's a huge difference and variance in the code as well as the functions. So if threads do not release the GIL voluntarily, then it's time to snatch it away from them. Now, so there needs to be something which does this process, and there's something called as check interval, which is a global counter out here. This check interval was earlier set to 100 ticks before Python 3.2, after which it was changed to a more logical 5 milliseconds. These ticks, they loosely map to interpreter instructions, and the concept of ticks is very vaguely defined in Python. To understand more about ticks, let's go a step further. So this is a simple Python function which does nothing but summation. Now, what interests us is not something on the left, but something on the right. So we have the disassembled code of actual sum operation out there. I've used the disassembler module, and you can see ticks T1 to T5, I've represented them. The surprising fact about these ticks is that there's a tick called as T4 out there, which maps to call function, and which is represented by print function in the actual source code. Now the fact is, this tick T4 itself takes 3 times longer in order to complete as compared to the sum taken by all the remaining ticks. So the concept of tick is a very crude idea to snatch away the GIL. Hence, we should have something which is way better than ticks. So this is a famous representation by David Beasley given out. He says that when we have 2 CPU bound threads and 2 CPUs, Python does not allow both the threads to run in parallel because of the GIL. So you can see there's in thread 1 there is a block called as 66,700 ticks. So this is almost 667 times longer than it should have actually been run. So this is just the case of CPU bound threads. When you have something with CPU bound and IO bound threads, it gets more difficult. So this is a simple canonical GIL trace out there. What happens here is there's thread T2, which is a CPU bound thread that is running, and there's thread T1 which tries to come in between and acquire the GIL, and literally it has to like crazily wait for about 16,000 ticks in order to acquire the GIL. And the most amazing part is, even if after it acquires the GIL, it just runs for almost 3 ticks. You can see from 100 to 97 at the bottom, it just runs for 3 ticks. And this is a very canonical example of priority inversion which we had studied in operating systems. So in order to ensure thread safety and threads do not lose the GIL in between, we can always try to accommodate or try to use atomic functions. So the sort is the atomic function out here which does not release the GIL. So having ticks for preemptive multitasking and snatching away of GIL was a really cruel idea. Hence, we have this new GIL out here which is completely based on milliseconds, and there is no ticks out here. So there's this guy called as Antoine Petru who rewrote the entire GIL, and he rewrote it with ticks eliminated. So these are some of the messages that appeared on Python bug tracker and mailing lists. So what matters in the new GIL is we have this Boolean variable called as GIL drop request, which is set to 1 once the timer expires, and as soon as the timer expires or the C interval expires, this GIL drop request is set to 1, which ultimately becomes an indicator for the currently running thread to give away the GIL. So it seems that everything is fixed right now. That's probably not exactly what we want. So there was this issue appearing on, again, Python bug tracker. Probably it was written by David Beasley. It was in version Python 3.3. So he points out there are certain flaws with the new GIL as well. So the first issue he speaks about is untimely wait, where even if the data arrives, it ultimately has to wait for those 5 milliseconds. The next is the unfair wake up, which says that thread T2, even if it tries to set the GIL drop request to 1, it may not be the one who acquires the GIL. There may be other threads pouncing on the GIL. And this is a canonical example of convoy effect with IO bound threads. So these are the 3 issues which were raised. So yeah, so everyone is pissed off with GIL right now, and the biggest idea of the year is to just remove the GIL. So there have been multiple attempts in order to achieve, like writing Python without GIL. First one was free threading patch by Lore. Second one was Atomic Increment and Decrement, written by again Antoine Petru. It was way back in 2000. And then there was this Gilectomy written by Larry Hastings. So Guido has his own say on the GIL. He says he would welcome a set of patches in Python only if the performance of single-threaded program does not decrease. So he has written an amazing blog. It isn't easy to remove the GIL, so I'll advise everyone to read that. Now, speaking a bit about Gilectomy, what Larry Hastings has done is he has replaced the giant GIL lock with multiple locks. He has used a new locking API called as PyLock and PyUnlock. So he has two different entry points. One is with GIL and another is without GIL. Now, to give a short overview of what Larry Hastings has done along in his Gilectomy journey is, the red line at the bottom of the plot you can see, that's the line of the score Python, stock Python out there. This is the wall time representation. So Larry Hastings started with the blue line up. That's way back in June 16 when he started it. So that's how he started like getting into it. And during May 17, he reached at a point where it became really close to the actual source C Python code, but yet I would say it's not very close. It's still very far. Larry Hastings even provides an update of Gilectomy in 2018. You can refer. I have attached the link for that. So that's pretty much about multi-threading. Moving apart from multi-threading and looking at the alternatives, we have something called as Cython. We have multiprocessing. There are certain alternatives to CPython as such. One is written by Armin Rigo. He has written PyPy with amazing software transaction memories. There's IronPython, there's Jython as well. So this is just a canonical example of using Cython. The code on the left is a sequential one, and on the right is a parallel one. So thumbs up to Cython, as the parallel one takes a little less time as compared to the sequential one. So there's this amazing company called as Parse.ly, which is like based out of United States. What they do is they produce real-time content analytics dashboards for different publishers. Andrew Montalenti, the CEO of Parse.ly, gave an amazing talk at PyData New York called Beating GIL to Max Out CPU Cores. So basically what they have done is, even if they were faced with multiple challenges, they have kept the GIL intact, and if they have not tried to remove the GIL. Instead, they have tried to overcome the challenge of GIL. So I would like to give a small gist or a small use case of which they were working on. So they were faced with this problem that what happens when you have almost 153 TBs of data that needs to be processed anytime, and it's like approximately growing about 10 to 20 TBs per month. So they used this problem, and they somehow overcome the problem of the global interpreter law to delve into a small use case of what they did was they had this heap of URLs which required some sort of processing. So they used the URLlib module and the URL parse function, but it really turned out to be very slow. Hence, they deep dived into the source code of URLlib module and found a function called as parse_QSL, which was the most slowest among among the entire code out there. So they rewrote the entire code in Cython, and the speed up was almost 10x times at the actual URL parse function. So coming to an end, I would like to say that GIL is a feature, it's not a bug. Instead of removing, let's think on making it better. So whenever you're dealing with heaps and streams of data, you should always multiprocess and avoid multi-threading. Try and achieve multi-noding as compared to multi-cores. You should always look for message passing instead of concurrency if you are comfortable with the IPC calls of message passing. Before closing off, I would like to give a small advice. Be curious. If you do not understand something that's going under the hood in Python, we have the source code of Python, we have the documentation, there are mailing lists out there, there are enhancement proposals. Also, you have blogs and code developers out there to follow and look upon. And I just want to say that it's not just about importing those libraries and modules. What matters is really understanding what happens under the hood, under those libraries, and utilizing them efficiently. So these are a few references out here I would lay down. There's a David Beasley talk on GIL. David Beasley is a research computer scientist, and he has his amazing explorations with GIL. Larry Hastings has given his amazing talks on Gilectomy and how he has, shaped the entire journey. Jesse has his own article on Grok the Gill, which is again beautifully written. Nina has a very amazing talk on memory management, where she talks about garbage, like cyclic references, garbage collection, and the entire memory management aspects of Python. And there's Andrew Montalenti, who gives a talk on beating the Gill. So that's pretty much from my side. And I would like to say a huge thank you to the entire PyCascades team for making this amazing, amazing conference possible for me remotely. And I hope you enjoyed, or at least you got something from my talk. So yeah, thanks a lot, everyone. Yeah. Thanks a lot. Thanks a lot, Tia. Thanks a lot.
Excuse us, ladies and gentlemen. 1, 2.
Up a tree, clinging to a cloud. Up a tree, clinging to a cloud. Up a tree, clinging to a cloud. Up a tree, clinging to a cloud.
here. Let's go back, 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 back.
gives them a satisfaction they couldn't get any other way.
in front of a live studio audience. Recorded in front of a live studio audience.
So I thought I needed. Thought I needed. So I thought I needed. My God, how do they walk away in movies without flinching when it explodes behind them? There's no way! I call bullshit on that! I need an MRI! I've got soft tissue damage! There's no way I don't have soft tissue damage!
Miniature Buddha, covered in hair.
Very, very loud. So yeah, we're gonna go ahead and get kicked off with lightning talks. So our first chat today comes from Alex Lord Thorson about improving reviewability with GIFs.
Hello, everyone. Can you hear me? All right, we're just going to get right into it. So there is a program called Askinema, or Askinema, I don't know how you actually pronounce it. And what you do is you say Askinema record, and then it will start recording your console output, and you can say run PyTest or run MyPy, and it will record that output. You hit exit, and then you can either upload it to their website, where you can then have embedded MP4 videos put into websites or something like that. But today, I'm going to make a console GIF from this. So yeah. We are going to copy the cast file. Then we are going to find Askinema GIF right here. Put in the input file. Go to the desktop, say example.gif. It's going to go through and it's going to take screenshots of the console output that was saved. In this case, it's going to do like 20 or 25, 23 screenshots. It's going to produce a GIF file for me, and then I'm going to go over to a GitHub page, because it turns out that GitHub, Bitbucket, Jira, and a bunch of other pages automatically display GIFs in line. And so you can have things in your code review, such as like a list of changes and an example that you can pull. And it will go and upload it for you automatically in Markdown. And then you can display it in line. I like to do this for console output. I also like when I change stuff in like Jenkins or websites like this, I like to take screenshots of the before and the after so people can give me feedback on what the actual review looks like. So it's not just code that you're looking at. And also, just because this is fun, there is a program called TTY-Rec, which is essentially the same thing. You can say make test, and it will go and make a TTY-Rec file. This is the first solution I found, and it's not a good solution. I just think it's really fun. Oh, no. And then what you can say is you can say TTY to GIF. And what this does is it runs every single character and takes a screenshot using the operating system. And it generates the GIF file. And I think this is a great example of a quick and dirty solution to a problem. Thank you very much.
That's really cool. Okay, cool. So our next lightning talk speaker is Jason Wadier on A Light in the Dark, the importance of mentoring.
How's the audio? Seems pretty good. So there are technical and non-technical talks. This is definitely a non-technical talk. Being in a dark room can be very disorienting, even a little bit humbling. Your basic sense of vision is robbed of you. And the solution to your problem, the light switch, may be all the way over on the other side of the room when it was just beside you. Coming into something new can be a lot like being in a dark room. That was me a year ago, January 18, studying for a Microsoft certification exam in C#. But although I was studying for a C# exam, I wanted to think about diversifying my technical portfolio, my own personal tech stack, to include something that was outside of the Microsoft family, just to broaden my career possibilities. And Python seemed to come up a lot, like a lot. But nobody at my workplace used it, except for a couple of grad students. Even they just use it kind of for some spot basis stuff. So I was in a dark room. But thankfully, I was not bound by the artificial premise of this setup that I've created to make a point. And I did what any normal person does in the modern age when they're entering in a new hobby or trying to learn a new language. I searched Amazon for books and Apple Podcasts for podcasts. And there were a ton of books. But podcasts, there were two that I quickly came across very quickly. This guy should look familiar. The two that I came across were Talk Python to Me and Python Bytes, where Michael K. always energetically starts the episode with, "Hello and welcome to Python Bytes," where we talk to you about Python news. Mangled that one a little bit, but what I got from listening to these podcasts pretty quickly was that it wasn't a cold, neutral, mechanical discussion on technical features or applications. This was a vibrant, energetic discussion of how Python is used in the real world and its impact on real people. This gets me to my first role of mentors or experienced people to newbies coming into the community or looking on the outside. As an ambassador, I think knowingly or unknowingly, whether you make yourself visible or invisible, the experienced people in a community are themselves representatives to the outside world or to outsiders or people that are just not initiated yet or just are on the outside looking in. So this was the bait that got me hooked, these cool Python podcasts that, of course, I didn't know what was going on. I didn't know what a pip install was. A virtual environment sounded like some type of science-forward movie from the 90s. But it was enough to think to myself, this is something worth pursuing further. This looks like it's more than just, syntax within an IDE or text editor. The next part was an incredibly seminal moment for me. There's a Talk Python to Me episode that I listened to that involved these two handsome chaps, Bob Belderbos and Julian Zakara, otherwise known as the PyBytes guys. Their episode focused on their personal example of doing the 100 days of coding movement, where they built a complete application in Python each day. For me, what was very important about this episode wasn't their achievement, but it was their personal circumstance. These guys were both dads with kids and full-time jobs. And that really resonated with me because I just had, with my wife, our second and third kids. And I was incredibly down on myself or not optimistic about my ability to learn a new skill with the new family situation. So these guys appearing on this episode and being living, breathing examples of some of the same challenges I was facing meant a lot, which gets to the second role of mentors. Inspiration or examples. You may not feel like you are or could be an example to someone, but as there are a million colors of a rainbow, there's also a million different inspirations. So again, your personal struggles may resonate with someone else. And I'll get quickly to the next one, the third role. And then we jump to PyCon. So I'm skipping over some parts in the story to get to the last point. Obviously, I had a little bit more hair then. Third role of mentors, guidance and feedback. Again, being someone new, being, eyes in a dark room, you don't know where to go, you don't know where to step to next. Just ask. Good recommendation. All right.
It's really interesting being on that side and watching someone slowly creep up. So good job on that. Okay, cool. Our next lightning speaker is Nick Ballinger, talking about something that I very, very, very much think is exciting, which is tech work in politics.
Okay, can everybody hear me? It's on.
Let's get the mic oriented towards you.
What if I just put it in my mouth?
Here, actually, real quick, let's.
Try. Okay, can you hear me?
There we go,
Good,
yeah.
good Lord. All right. So I've been in software for 15 years. I've been 10 of those in national politics, entirely on the progressive side. This is going to be a nonpartisan talk. I don't take a particular viewpoint, but we're in February of 2019, which means we're solidly into the 2020 races because America is ridiculous. And I thought it's possible that somebody might be thinking about getting involved with a political organization or campaign, and I wanted to give you a kind of rough survival guide or sort of what you might expect, because it's a real different domain. Okay, so what do you think you could do on a campaign? You can do infrastructure, ops, security, data analytics. Those are always a big team. Content management, God knows there's lots of that. If you love, configuring a content management system, you can do that over and over and over. And there's also development work, which is usually kind of freaking out, smashing things together, and pushing out some, I don't want to say embarrassing product, but you'll feel bad. Just since most of us have probably worked in the corporate domain, I want to highlight some of the kind of differences. So tech companies, you have a value proposition around sales. When you do a startup, it's usually fairly small and slow, and you've got a little bit of time. These are super broad generalizations because I have 5 minutes. Funding. Typically, you get funding, increases your runway. That's great. When your value proposition is being worked on, you typically get incremental validation of it. So people tell you along the way, like, yeah, that sounds really good, I'd buy that. Or you start selling a product and people do buy it. The business models, despite our love of disruption, are typically fairly established. You sell a product or a service. The labor pool in a tech company is pretty continuously available, and it's mostly made up of professionals. Political campaigns are a different beast. The value proposition is votes for a candidate, which is a very strange thing to try to convince people to do. You're not buying a widget for your home, you're bringing yourself into alignment with some belief system and personality. So working around that makes everything a little weird. The startup curves tend to be totally asymptotic. It goes from nothing to hire as many people as possible today. And I'll talk about why in just a minute. If you get funding in a political campaign, it doesn't increase your runway because election day is coming. It increases your burn rate. So you get money, you burn money. And you got to spend money to lose money. Validation of your value proposition happens one time at the very end. It's pretty strange. The business models tend to be totally emergent and chaotic because every time you form a campaign organization, you get a bunch of people together arguing about how to run it based on all the stuff that happened the last time, and it's all totally different every time and for every campaign. The labor pool is totally contingent because you have to convince people to work on your crazy project, and you've also got to tell them, essentially, I'm going to employ you maybe 2 years out of 4. So go find something to do with yourself for those other 2. Okay, that's a lot of what. And part of what I wanted to do was sort of demystify some of why these things happen. What drives them? Boundary conditions. And the boundary conditions are when you form your campaign and when election day hits. So that's a hard limit because the FEC says before you form a campaign committee, you can't hire anybody, you can't do any organizing, et cetera, et cetera. There's a ton of very strict rules about what you can do. So once you get started, you better start hiring people, and you got to get people who are just as nuts as you are. Then you got to force those people to work by coming up with, ridiculous stuff for them to do. And then finally, you get to the final push. Typically, this is October. So you work for a month solid, and you freeze your code, in whatever terrible state it's in, and then you go to war with the army you have. Once it gets to election day, it works, it doesn't work, who knows, it's over. Because you have what I call a Kool-Aid Man moment, where either you break through the wall, and you go, oh yeah, or you smash. That's what happens to political campaigns. Okay, so there's some crazy emergent effects that come out of that. One, data and code are assets. Campaigns always, always, always end up in the red at the end of the cycle. That means you can't pass that code or data to anyone without selling it for millions of dollars, which is why if you've ever thought, didn't we solve this stuff last time? It was all locked up. Can't get it. Let's see. Am I at my... Yeah, you're done. All right. Well, fuck it, don't. Yeah. But at the very end, all right, I'm going to say one last thing. Is it worth it? Yeah, it's still worth it. And the reason it's worth it is because, point 3, America is load-bearing legacyware, and every one of us is on call. Hey, no, I'm going to keep this.
Okay, so I don't know if that inspired you or made you just more fearful, because there's a lot of things to be fearful of. But our next speaker coming up is Marietta, who's going to be talking about mentored sprints at PyCon US. And I did just want to say that Marietta actually did receive from the Python Software Foundation the Community Service Award last year, and her write-up about that award is on the PSF blog. You should check it out because she has done a lot of really, really good work for PyCascades.
Thank you. Okay, I want to talk about the mentored sprint at PyCon US. This is one of the hatchery program accepted this year. something new, something we're trying, and it will take place on Saturday, May the 4th, 2:30 to 5:30. 5:30 or 6? I think it's 6:30, sorry. 4 hours, and it's part of PyCon US. You need to be registered for PyCon in order to attend, and that's the entire website with all the information. Now, why are we doing this? I contribute to open source. I realize it's a huge privilege, and this privilege is not evenly accessible to everybody. It's not enough to just want to contribute. You need to invest a lot of time, free time. That means you will have to do all your work, take care of your family, and then have free time to contribute to open source. It's not easy. It's not enough. I know a few people who can't even afford a computer. They could not contribute. So we realize this is a barrier. There are lots of barriers to contribute. And because of the privilege is not evenly available to everyone, the open source community, contributors, is not very diverse. Just if you want a brief exercise, think of open source maintainers that you admire. Come up with a list. The first 3 people, 10 people that comes to your head. How many of them are women? At what number? Do you come up at 50 and then you have a woman? Or people of color, trans people, disabled people? Are they on the top 10 of your list? Women of color. It took 20-something years for core Python to have women in the core developer. There is a lack of diversity, and we all need to recognize that. And it's not enough to just talk, saying let's improve. I want you all to participate and take action. So please do participate. We have sign-up forms available, and you have to apply before March 14. And we want to prioritize attendance from underrepresented minorities. If you don't consider yourself a minority, I would encourage you to share this news with a minority people. Come, take them with you to this event. And if you are an open source maintainers, you can sign up. This is not limited to Python projects. It's not limited to big, huge, popular projects. If you have an open source project that you maintain, please come and mentor, sign up. And we have a number of submissions already, people who said, I want to sprint, I want to come, I want to contribute. So far, these are the projects that they are interested in. So if you know open source projects in this field, web development, scientific, education, please come and sign up. And again, come check out the website. It will be Saturday, May the 4th at PyCon US. So thank you so much. Feel free to call, Twitter me, Slack, or email me about this if you have any questions. Thank you so much.
Awesome. Very cool. And then for our last lightning talk speaker today with Casey Feist, who's going to be talking to us about data classes. And as a side note also, there are additional programs that are in the hatchery, which was born as kind of a way to have experimental tracks at PyCon. So for example, PyCon Charlas, which are the talks in Spanish now, are a standalone thing that are happening at PyCon US. And there's more you can check out on the website. But now I'm going to turn it over to Casey.
All right, everybody, I want you to take a deep breath with me, because I'm nervous, and it's the end of the day, and we're all tired. So hold on, let me get ready. Okay, everybody, deep breath in. Okay, let's do it again. Deep breath in. I feel better. Do you guys feel better? All right, data classes. So I have been to so many meetups where this is the story. You show up, you've got your pizza, you're hanging out, and then people start talking about this data classes thing. They're like, oh, it's the best. It's coming out 3.7. It's like the future of classes. Like, it's amazing. And you're sitting there being like, oh, okay. That sounds good. It took a while. Like, this took me by surprise. I didn't know where this feature came from. And I noticed that I wasn't alone in that. There are a lot of people who are like, so what is a data class? What do I use it for? So, a quick example. So you have a class, a wallet. You would like to store some information in there. It's mostly just for data store, right? And you want to be able to check the amount in the wallet. But you'd also need to init that, and you want to be able to equal it. You want to change the base way equal works, so you expand it a little bit. And then there's some hashing weirdness that you don't want to get into based on the way that you're storing your data. And then there's some more stuff that we can add until this class that is for storing 4 variables gets a little bit out of hand. Or, ta-da! This is a data class. Yeah, clap, yes, feed me. Excellent. So, this is a data class. This is essentially what you're buying with the data class. You're buying a lot less writing. You can use this nice annotation style to specify what we call fields. These are fields to specify your data. And this allows you to have a very flexible, customizable data store. It's great for state. It's great for passing information around your application. And it's great for writing less code. But where did it come from? That's cool. I wouldn't have thought of that. Where did it come from? Blasphemy. Actually, not so much. For tuples, named tuples, we have that dot notation that you see in JavaScript. But for normal Python dictionaries, we're still using this brackets notation. If you have an 83-line piece of code, and you switch from the brackets to dot notation, you now have an 80-line piece of code. So you can see here, this is an example of JavaScript where you're setting that object. Look at that dot notation. Isn't that nice? I want that. There was also, I did some digging into this project and found this really interesting Stack Overflow post about how to do C-like structs in Python. This has, at the time that I took this screenshot, over 400,000 views. Like, it's a popular topic. And lots of the discussion centers around something called named tuples, which also got an update in Python 3.7. This is great, but it's not very flexible. There was an excellent talk on tuples earlier. I recommend you go check it out by Al. But this is one way to do this. This works for a couple of specific examples. What if you need flexible? What if you need it to be immutable? What do? Use data classes. So a need felt by programmers who had experience with C was addressed with this in our language, because languages do not evolve in a vacuum. They're responding to each other. They're changing in response to what people see and observe across. That's been a theme of this conference. It's really cool. But, yeah. But wait. There's a project out there that actually has a lot to do with this yet. But there's a couple reasons why we want to use data classes, and not just adders. Adders are great. If you have a project that uses it, continue to use it. But this allows core developers to use this data class idea within Python core itself. We're looking at how Python itself is being built and what they're looking to, they're building the tools to continue to build Python, which I think is just so cool. Yeah. That's my talk. This was originally a 30-minute talk, so I'm really excited that I got under the limit, but thank you so much. If you want to talk to me, I'll be outside. Cool. Someone relieve me.
Hi, folks. So next we have Margaret from Twilio, who's going to give out prizes to the Twilio Quest participants. Would you like us to wire you up here?
Okay, so thank you all for playing and earning a ridiculous amount of points. That's pretty awesome. Yes, well done. So I am going to tell you what the prizes are, and then I'm going to work down the top 10 list, and the first 3 people that are on my top 10 scores and in the room get to come pick a prize. I know. Okay, so if you have not selected Pi Cascades 2019 as the event in your profile, you'll need to do that or you won't be on my top 10 list. So while I'm announcing what the prizes are, go ahead and do that right quick. All right, so the options, and if you're first call, you get to pick first, second, third, etc., are Women of NASA Lego Kit, Marvel Codenames game, and the one that I hope no one claims so I can take it home, Super Nintendo Classic Edition. I love buying toys, you might have noticed. All right, I'm going to hit refresh on the top 10 list. Okay, so in first place with 1,700 points is Alex, all caps, exclamation point. Is Alex in the room? Oh, it's so sad, Alex. All right, in second place with 850 points is Hunter UWT. Is Hunter UWT in the room? Oh. Yeah, you should probably come down if you want to pick a prize, or I can just have your prize. That's fine too. You want to tell me which prize you want? Yeah. So sad. Okay, so the next winner we have with 650 points is Outrigger. Is Outrigger in the room? Yeah? Come on down. And with 600 points is Elsadora in the room? Going once, going twice? Yes? Yes! Yes! Which of these items would you like? Probably the Marvel one? Definitely the Marvel one. Women in NASA! Thanks y'all so much for playing, and you can still win my arcade prizes if you're playing Twilio Quest, but the big prizes are now gone, including my dear, precious Super Nintendo. Thank you.
Exciting for me. I actually came into programming out of a musical background, so I'm pretty excited to hear this next talk. Kyung-Yun Lee has come to speak to us about what is your musical taste. This is a hard problem to define. I'm really curious to see how this goes. Cool.
Do I have?
You're going to be presenting this is what everyone's going to see. So
Okay.
Start presentation.
And you're good to go.
Thank you.
You want the clicker?
Um,
I need to look it up.
maybe I can just use this one.
Did our previous speaker walk away with it?
It's possible.
Looking for one clicker, please.
Oh, it's right here, right here, right here.
Right.
Well, we have a spare.
There you go. All right. Hopefully it still works.
I'll take blame for that.
Just to get out of this.
And there you go.
Thank you. Can I start?
Yeah.
Yeah? Okay. Okay, hi everyone. I'm Kyunghyun Lee, and today I'm going to talk about, so tell me, what is your music taste? So before I get into talk, I'll introduce myself. I'm a master's student at Music and Audio Computing Lab in KAIST, South Korea. And my research area is called music information retrieval. So it's like extracting some information from music and apply it to like real world applications, like for example, recommendation. And for me, like I use combination of music or audio, signal processing, and machine learning to achieve that. And many people might be wondering why I'm here all the way from Korea. I grew up in both Korea and Canada, so I lived in Victoria for a really long time. So that's why I'm here. So today, the main topic is music taste and recommendation. So first, we'll talk about why we should care about such thing. And then second, we'll learn about how to model music taste. And I'll introduce Statify, which is a website that I built. And then lastly, we'll briefly touch on the concept of music recommendation. So first, why should we really care about music taste and recommendation? Because, you know, we all love music. I don't know why, but the sound is not coming on. But we love different music. Oh, it's fine, yeah. We love different music. For example, some people might like really heavy metal. Some people like acoustic pop. You know, like some people like BTS. We like combination of different music. And most importantly, we love different music with different reason. What I mean by this is that two people might like the same music for a different reason. You might like it because the lyric is really good. You might like it because the bass line is really good. You might like the singer, or you might just be a fan of the artist. So we got this. We know that music taste is diverse. Every single person is different in the world. And we also have another problem. There are way too many songs in the world for us to listen. So let's say one song is around like 4 minutes on average. And I'm going to say very roughly, there's like 50 million songs in the world or in Spotify's database, for example. In order to listen to all of them, it will take 380 years, 6 months, 6 days, 9 hours, 20 minutes, so on. And that's impossible for humans, right? And there's also a website called Forgotify, where it will give you songs that have never been heard or have been only heard very few times on Spotify. So you can go to Forgotify and find out what the song is. So the job of the recommender system is like going through the stars, and it will find songs that you will like out of those. It will find songs that you will not like, not your friends. So, and the importance of recommender system is that we live in a world that is full of data, and we need to continue to filter out what we like and what we don't like. So having a recommender system is quite useful, especially in today's world. So then, how do recommender systems really, know my music taste and differentiate my music taste from my friend's music taste? And we'll go through 2 parts. The first part is to model music taste, like individual person's music taste, and we'll learn about how to do this. What I mean by music taste modeling is I'm going to quantitatively represent a very descriptive and subjective music taste into numbers, because we all know the computers only understand numbers. It's not going to understand something like, oh, I love to listen to heavy metal with screaming vocal, dark and chaotic sounds and blah, blah, blah. It will not understand that. We want to process that into numbers so the computer can do something about it. But music taste is very difficult to describe even to your friends. For example, I looked at Reddit. I Googled, like, how do you describe your music taste? And there's some strange things like musical ADHD, which totally kind of makes sense. I agree with that. So how should we really model or represent this music taste into numbers? I'm going to introduce Statify, which is a website that I built just for fun, relating to like my research and stuff like that. So I'll have the link at the end of the slide so you can check it out. Now it uses, I built this with Django, Spotify Web API, and SpotedPy, which is the Python wrapper for this API. And I use various visualization libraries like PyGal. Also, for computing and machine learning, I used NumPy and scikit-learn. So Spotify Web API, it offers lots of different functions like searching for a track or album or artist, creating a playlist, showing the current user's top tracks or albums, and etc. But my favorite part of the web API is they provide audio features for each track in the database. So for example, the example audio of the audio feature is danceability, like how danceable is the music. 0 is like not danceable at all, and 1 is very, very danceable. And acousticness, is the track an acoustic track or is it not? And also, for example, like valence, how positive or how negative, like how sad or how happy is the track. So these are some of the features that are provided by the API. And it's very easy to get that feature if you use SpotedPy, the Python wrapper. So you just do the normal thing, like you go to the Web API website, you get your client ID and all those things, and you do the authorization. And you need to initialize the Spotify Web API object by calling the SpotedPy.Spotify. And each track in Spotify, they have a unique ID. You can get that from the web app of Spotify. And you just call SP, the object, .audio features with the track ID, and then you get something like this. It's like a JSON or a dictionary of all the audio features plus other metadata. And I got an example for Island in the Sun by Weezer, if anyone knows. So how are these audio features computed? You know, like how does Spotify get these audio features? For example, for the Island in the Sun, if you see acousticness is like 0.00719, danceability is 0.654, and etc. So how are these computed? So Econist is a company that was founded from MIT Media Lab in 2005, and they're very famous for creating a really large music database, and they use a lot of techniques like signal processing, machine learning, and web crawling to collect a lot of data for each of the tracks. And in 2014, Spotify acquired Econist. So since then, Spotify has been using the database that Econist has created. So this is how all those features are there on the web API. And I'm going to use 8 of those audio features to model tracks in for Spotify's tracks, for example. So I'm going to use 8 of 8 as such: danceability, energy, loudness, acoustics, blah, 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 until tempo. So for the Island in the Sun, this is how I'm going to model it. Island in the Sun will be represented by just 8 of these numbers. And the most important thing is the order of these features must be consistent when you're modeling all the other tracks. So you don't need to follow my order. You can order these in any order you want, but you need to be consistent throughout your application. So we just modeled a track with 8 numbers. Then how can I model my music taste with 8 numbers? I'm going to use myself as an example. I got my top 50 tracks that I've listened to the most in the last past month or two. And these are the artists. I have quite a lot of like rock and a little bit of like jazz. So what I'm going to do is I computed the audio features, the 8-dimensional vectors. I modeled each track in the my top 50 tracks into 8 numbers. And I'm just simply going to average all the features so that it can represent my music taste. So that's me there. So my music taste is now represented with just 8 numbers. And this is simply the average of all the features from my top 50 playlist. And I'm just going to show you like what Statify, the website that I built, it shows top 10 genres I've listened to the most. And as you can see, I listen to mostly rock, like various kinds of rock, and a little bit of pop. And also, I plotted the box plot of all the audio features. So how you read this is the bold line through the middle is the mean of the audio feature, and the height of the box is the variance. So what I think is that small variance might mean that you really care about the feature. So for example, the green one at the top, the small box, is the loudness. So I seem to really like loud songs. And if you see the box in the bottom, the orange box or red, I seem to really not listen to live recordings of songs. I tend to listen to the actual original track, recording track. So you can interpret all sorts of things from this box plot as well. And I also offer another feature where you can compare your top 50 playlist with the popular playlist that is provided by Spotify. So these 3 are playlists that are provided by Spotify, and it features really popular tracks from around the world. So I'm going to choose the global top 50, and this is from I think 2 weeks ago. So as you can see, Ariana Grande is at the top, and we have other artists. So in the app, in the website, I'm going to click Global Top 50 and My Top 50 and do analysis. And this is the histogram of these 2 playlists. And what you can see, my top track is orange. So I can see that my tracks are less danceable than the Global Top 50 tracks. And in general, mine has a bit more energy, and so on. And you can see that the popularity at the bottom, the middle bottom, I listen to songs with less popularity and also a lot of popularity. And obviously the global top 50 has it's all popular. So you can check that out on the website. So we have represented music at a track and your user taste with 8 numbers, but I chose 8 numbers, 8 of the audio features, but are these really sufficient to really represent music and user taste? And I'm going to do a 3-way comparison. I'm going to compare Discover Weekly, which is a playlist that is recommended to you every week. So it knows your music taste. Spotify knows your music taste and will recommend some songs to you. So it has, I think 20 songs, I'm not sure. And I'm going to compare that with the Global Top 50 and My Top 50 and see how the tracks look like. But the problem is, I have 8-dimensional feature vector, and I can't plot that into 2 dimensions, which is the space that we have on the screen. So I'm going to reduce the dimension to 2 using one of the technique, principal component analysis. So it just finds 2 most meaningful feature from 8, and then it will reduce down to that. And this is the result. So as you can see, each dot represents a track. And for example, that red dot is Bohemian Rhapsody by Queen, and the blue dot is Psycho by Muse. And as you can see, the big red dots are the global top 50 tracks. They're clustered in the bottom left corner. And Statify, which is my track, it's really spread out. And surprisingly, Discover Weekly is also, it kind of looks like my taste. So from here we can see that just using 8 of those audio features, it is sufficient to really describe a track and describe user taste, because we can see that it represents my music taste instead of the global top 50. And Discover Weekly does a really good job. So we have just finished modeling user taste. So the next thing is we just need to do recommendation. And recommendation is very simple. It's just like ranking. So it's going to rank the songs that you would like the most to the songs that you would like the least. But in order to rank, you need some kind of a metric. And I'm going to measure similarity from my user taste to all the other tracks in the database and then find the songs that is closest to my music taste, because all the user music taste and the tracks are represented with just 8 numbers. And out of many similarity metrics, I'm going to use cosine similarity, which is measuring the angle between 2 vectors. And you can write your own function with Python very easily, but I used scikit-learn's function that's provided, which makes it very simple. And recall that my music taste looks like this with 8 numbers. And I took 4 tracks as an example, some rock, folk, pop, and I represented them with 8 numbers as well. And then I'm just simply going to compute cosine similarity between my music taste and the 4 tracks. And here I have Basket Case by Green Day, and I compute it like that. It's very simple. And then I ranked. And it does really good, because if you can recall, I listen to mostly rock and a little bit of pop, and it does rank in the correct order, so we can see how the recommendation actually works. And this is how the content-based recommendation works, and even for Spotify, they use content-based recommendation as well as other types of recommendation, but this is how it works in essence. So we commonly have 2 types of very popular recommendation methods that's currently used in many of the services. And the first one is just what we talked about, content-based. And content-based means using the content of, for example, music. So we use audio features, which really describe how the music sounds like. And you recommend similar content to the user. And then the second one is collaborative, which doesn't use any of the content information. It only uses other people's user data and my user data. And user data includes listening history of the song, likes, artist follows, and etc. And I'll explain a little bit more about what this collaborative method is. I brought and I'm going to explain what collaborative filtering is. And collaborative filtering is a very popular recommendation algorithm. It was popularized by Netflix. And how it works is we have Hiccup and Toothless. And Hiccup, the boy, is I like H for Hiccup and X and Y and Z. And then Toothless says, I like T for Toothless and X and Y and Z. And you have to note that here they have X and Y and Z in common that they like. And then the CF algorithm genie comes and thinks and says, Hiccup, I think you will like T. And then this genie tells Toothless, I think you will like H. And guess what? Will they be happy or not? They'll be very happy. They'll be very happy. Because the CF algorithm, it assumes that people who have liked similar things, they'll have similar taste. So they liked X and Y and Z in common, so the algorithm recommended the ones that each of them didn't listen to. And it works really well. And as you can see, Netflix works really well. Netflix it's very well known to use this algorithm. So recommending without user data, it works. Only if you have a lot of data though. Okay, then we talked about modeling with 8 audio features and all these things. So why did we talk about all of that if CF algorithm that doesn't use any of those content information works well? Because CF algorithm has a really big downside, and it's very well known for cold start and long tail problem. And cold start problem, you'll understand why it's named cold start. For example, a new user registers to Spotify. That user have never listened to any of the songs because he or she just registered. So in that case, the algorithm cannot recommend any songs to that user because he or she didn't listen to any of them. And also, if an artist released a new song, no one listened to that song yet. If no one listened to it, we can't recommend that to another user. So this is a really big problem. And secondly, we have a long tail problem where songs on the tail end is less popular, so CF algorithm is unable to recommend the songs that are less popular and people didn't really listen to. It will only recommend the songs in the popular side. So if you use CF algorithm only, you'll see that your algorithm continues to recommend popular songs, not the songs on the tail end. So it's very hard to do discovery of new songs, for example. So the next step, as you can see, is, okay, let's combine the content-based and collaborative filtering, and obviously you'll think that'll get better. And it really does get better. And a lot of services, for example, like Spotify, they do both content-based and collaborative filtering method. And I'm not going to go on to explain how they do that and everything, but I included some references at the end so that you can read a little bit more. There's a really great blog post and some research papers on this. And you can ask me any questions if you have. And yeah, now you know how your music is recommended to you every day, because I'm sure a lot of people use Spotify and also wonder how it knows your music tastes so well. So this is the references. There's also, I included a paper that is like in progress that me and my friend is writing. And also these are the libraries that I used just as a reference if anyone wants to try it out. And this is the website. The code is not optimized, so it's really slow, but you can check it out. Hopefully, like, it won't break if everyone logs in at the same time. I've never tried that, so. Okay, thank you, everyone. Oh, I need to bring this.
you are too demanding or too greedy, your mind is not rich and self-sufficient. When your mind becomes demanding, when you long for something, you will end up violating your own precepts, not to tell lies, not to steal, not to kill.
south and eastward. The central and eastern parts of Kansas will very probably be cloudy.
Check this, yeah. Well, that sounds like it.
Begin to get increasing cloudiness by tomorrow afternoon. Today, however, very, very pleasant reading, 73 up in the Goodland area.
And yeah, good.
I think we'll be ready to go, so.
I've switched.
So Fairbanks.
Geophysics.
Geophysics, satellite imagery, fires, fun and exciting stuff like that. All right. So I'm going to call us back to order here. Our next speaker is Chris Weigel. She comes to us from the University of Alaska at Fairbanks, so down out of the frozen north. She is a geophysicist and works largely with satellite data, looking at forest fires and things like that. But today she's going to be speaking to us about how to make ourselves better programmers. So hands together for Chris.
Well, first, thanks for the organizers for putting on what I think is an awesome conference. Thanks for the volunteers, sponsors who make it possible. The transcriptionist is doing an awesome job. thanks to University of Washington, whose beautiful hall we are standing. And I also would like to acknowledge that the land we're standing on is the traditional land of the Duwamish people and of their neighboring tribes of the Puget Sound. And you may have seen some of their art around town. I see a lot of it. The topic of my talk is about being a student of all the things. And you, one second. There we go. And you may know this cartoon from Hyperbole and a Half, all the things. And it speaks to me because I think I've always been some sort of student and sometimes an instructor. And many of us are also students of Python on their own, not necessarily in a formal setting, in a software engineering or computer science setting. And I am as I said, I'm an earth scientist. Earth scientists write programs. I shuffle around a lot of data. I do visualizations, make maps, and sometimes I do some machine learning. And I sometimes teach programming. I had the opportunity to teach programming to undergraduate and graduate earth scientists and mentor students with their programming, often in Python and other, often open source or other non-open source languages. And it's a little secret that scientists or students, and I'm just kind of use it really broadly, you know, pretty much everybody should somehow fit under student somewhere, often write kind of quite mediocre or bad code. And that's really well known if you just go out on an internet search engine of your choice and look for examples, and there are many examples where people talk about how scientists' coding is really not up to par. There are big problems in you know, looking at the code oneself. Often the code is not available. If it's there, it's not documented. If it's documented, weird approaches to testing. This is Alice Harpole writing for the Software Sustainability Institute. It's difficult to work out how it works, how it runs, and that's kind of not really good for science, right? We want to be reproducible. We want to do something that others can check, and it's code, and there's data, and it should be easy to run. This is a writer, Bojidar, I think, maybe I'm pronouncing it wrong, and he seems to be having a pretty often quoted article about this exact problem, and he just rips into it. Can't write good code, they write code simply, and this is actually really interesting. He makes a good analysis. They write code, we write code simply to achieve our immediate goal. We get it to work, it works, and then we hand in a paper for our professor or write a paper or we're done. Or like the data is now where it should be. And so we throw it away afterwards. Bojidar here quotes all sorts of software engineering things, API design, code coverage, code quality, and he says these things are rarely done properly in the scientific community, and he's right. Then here's a guy called Neil Saunders. He's a data scientist, and he quite openly admits, yeah, it gets ugly, and he says basically what we're doing is we are writing our exploratory data analysis, and then we're done, and we're never getting around to actually cleaning it up. So people, of course, are constructive, kind of. They propose some remedies. For example, teach scientists code organization, all the stuff that software engineers know, or hire software programmers into the research institutions. And some are kind of bold and say, it's all good. We need to make a mess, and it doesn't matter if it's bad. Well, I don't actually believe that. I think it does matter. And I also think that all of these things, other than the third, are good, are important, and are right. But they're not all of it. What about the actual code? You know, even if I teach all the software engineering practices and version control and organization, people don't magically become better coders. And what I'm trying to convey today is that we can and should also work either ourselves or with people we mentor. And I was really lucky. I had excellent mentors with Python and still have excellent mentors. That we should really work on writing better code. And the second proposition is that we, looking through the lens of abstraction and thinking a little deeper what is meant by the term abstraction, can help. And this is how. Abstraction, the way I understand it here, is actually starting like at the basement level, not like up here at object-oriented design, some book with a very abstract book, like you're staying like down here. Just abstraction. Abstract is the opposite of concrete. Abstract is about how I conceptualize something, what the mental chunks are that I use to think about something. And if you look at the Python documentation and look for the term abstraction, there are a few really good places where it comes out, and one you've already seen in the second talk by Al Schweigert, exactly the same passage that he quoted. Section 3.1, object values and types. He was interested in the values. I'm interested in the first line here. Objects are Python's abstraction for data. We know in Python everything is an object, and there is data, and an abstraction is what how the object represents the data. And there is, at the end of this paragraph, also a little thing. It's not just everything is data in our model, so even code is data, so it's not just about data, scientifically speaking, but also code. Then in several module documentations, we find something about abstraction. Here, this is URL-lib documentation. It says this class, the URL-lib.request.request class, is an abstraction of a URL request, meaning we get a class from this module, and it represents, it's an abstraction for a URL request, which in some ways is more concrete. It's something that actually happens on some level in the real world. This is from the SSL module documentation, and here it talks a little bit about how SSL sockets are an abstraction, and also similarly OS level sockets. So the socket idea in this module is an abstraction for something that happens. There is also a little warning that you can find in the programming FAQ, and I will just put this here and come to it later. It says a little bit, it says in the performance section that if you create abstractions, it has a performance cost, and it has this idea of excessive abstraction. So it's a hierarchical thing, or at least it's a level thing, a layer cake of abstractions that are building on top of each other. And this FAQ says, well, be careful, don't abstract too much, whatever that means, and we will come to it. Yeah, note the levels. Now, if I say abstractions, is this something that students or beginners in Python will take years to get to? Well, no, not at all. You deal with abstractions right away. And I'm giving an example, and, well, I will talk about it. Like, let's say I'm still having my scientific student in mind who, for example, might want to open a data file, and someone gave them the data file in JSON format. So you would just read the content of the file into a variable called data, which might be, well, I hear is another option is like you have it in a string, so you use JSON.loadString. And here's an example of like a data set, and there's maybe some sort of measurement. There's a species, Betula, that's a birch tree, and a date stamp when it happened, and a temperature, whatever, you know, just some dummy data. So I'll come back to this. If they do this, and you look at the data dictionary the output will be a dictionary. You look at the dictionary and look at the value data set of temp, you get 28.4. Data set of date stamp, you get what's written there. I tried it, really. So this date stamp, what is that, abstraction-wise? Like, what is the nature of it? What is the type of it? It's a string. It's not a date stamp. It's not a date type thing. It's a string thing. And I cannot tell you how many times I saw people that I meet in academia stumble exactly here. They read some data in. You see the temperature comes out as a floating point or something, okay? In this case, we are kind of in the right category. It's a number, it stays a number. But this comes out as a string. And then they want to do something with the string. They want to reformat it, and they think about it as a string. So they start to substring it and slice it, and then they convert it from string to integer, and then they add something, and then they have to put it back together, and then they remember there's a datetime module halfway through, and instead of taking 2 lines to convert this here with strip time and struff time, they take ages and they have very error-prone, non-readable, non-portable code. Because they stuck there at having a string instead of saying, what I actually need is a datetime object and not a string. It's really simple. And I've had many students go, ooh, really? That's how I should think about it. You would think, I'm sure that pretty much all of you or many of you will have passed over this point, but if you mentor someone, stay there and give it a moment. So this was just a basic example. How else do we encounter this in Python when we work with it, when we learn it? Well, duck typing is about abstraction and abstraction levels. Again, from the Python language referent, an object's type determines the operations that the object supports. And if you teach someone or work with another language that is not Python, it's another interpreted language, often enough you don't come to this point where you think about the operation that something supports. You just have lists or arrays or whatever that go one way and then some other data type that goes another way. Whereas in Python, it's really important to think about that. And usually it goes in 3 steps. For example, with the most basic thing, a for loop through a list. You have many beginners who write this. They've had a programming class. They learned that you have to get through a list sort of thing or array sort of thing, you have to have an index and you increment the index. And that means that they think about this list in a certain way. They think about this list as something that has an index and that I have to increment to get through it. And I'm sure under the hood that is absolutely true even for Python, for CPython. I'm not sure, I'm just guessing here, but we're writing Python and not C. And that means that the student is not wrong. It's just the wrong abstraction level for Python. So we teach them, this is how you should do it, 4 element in my list. And when we teach them that, we also switch how they think about lists in this case. They think now about list as something that has elements, and that elements can be accessed sequentially, and you get the sequence automatically. You don't have to worry about it. You don't have to define an index. What I didn't give you here was that, of course, sometimes we want an index, and then we can use enumerate, right? So we don't use the first version at all anymore. But this is only step 2. And then step 3 is the one where duck typing comes in. Now we teach them it's not just lists. The exact same code for element in my iterable works for any iterable. And then this is really not to the big gotcha. It's really something that I think Python is really good about because Python is so consistent about these things. It's very much designed with attention to detail in these areas. In MATLAB, you have also a for element equals something thing, but it's element equals my vector. Students get really confused about that. Anyhow, another example, just briefly to mention it, is file-like objects. You can turn all sorts of things into file-like objects with, for example, the I/O module, and also sockets or serial interfaces. If you do CircuitPython, you want to have serial interfaces. You can read from the serial port, work just like that. So you turn everything into something that you access by opening it, by reading from it, maybe writing to it, and closing it, which is like a file. So at one point, you get to the point of getting to write your own abstractions. And that happens, for example, the first time when you write a function. Because a function is about how to segment a processing flow, like I'm thinking again mostly about the prototypical sciencey student, there is some processing to be done, into steps and functions, and then if you write bigger things, modules, packages, maybe you release something. But this is also a question about what are my mental chunks? It's an expression of how you conceptualize your task. And what this gets you is reusing, passing around data, and also hiding your implementation choice inside your functions. And you access just the API that you just created yourself. I call this abstraction for problem solving. Then data representation. It's very similar, but slightly different because you think sometimes about what comes first. Is the main thing I'm talking about the data, or is the main thing the operations I do? If we heard about these neural networks and other model building and machine learning, often enough you think of your functions first. In this case, the data is already standardized in some sort of API that you get from Pandas or NumPy or something like that. But then you think about your conceptualizing of your model building, validation, etc. You develop the abstractions for your data and the abstractions for your processing steps hand in hand, and they have to fit each other. With a library, you get certain things for free, and then you bolt on that. Also, the data representation in the end decides what your objects are, whether you work with a table-like thing, which I don't, or with a Pandas data frame, which is a thing you get used to. You get used to certain properties that it had, or a NumPy array, or if you stay within the standard library, a list, a set, a dictionary, you get used to thinking about the objects in what they are. I call this like reasoning about the overall shape of your problem or problem domain that you're working on. And tying it together, the transition to the object-oriented design sense of abstraction, where you then work about encapsulation and things I've really only personally don't feel like an expert about at all, it becomes quite natural. What's kind of sad is that I know a lot of scientific Python users, even quite well-versed ones, would never ever write their own objects. They just write procedural code and everything. They write functions, but if you think about it like this, you get actually quite naturally to writing objects. At least that's my experience with my students. And we can talk quickly about, we have a transition to what the computer science and software engineering people learn in their object-oriented books. Last, and to just kind of come to the little, and I'm not saying, rah, go ahead and abstract everything, abstract all the things. There are some pitfalls here that you need to be careful about. The notion of leaky abstraction, I forgot who actually created or invented the idea. The idea is it's leaky like a sieve, you know, there's water coming through. You can look through one level of abstraction through the underlying level, and Python is actually kind of quite leaky. We saw the talk about debugging showed us some error messages and how error messages or exceptions sometimes don't actually tell you where the problem occurred because it's hidden within successive function calls. Sometimes you really don't know, like if you forget, if you do mistakes, if you make mistakes where you use brackets instead of parentheses or vice versa, you get very strange error messages that have nothing to do with what your actual problem is. Sometimes just these messages are on the wrong abstraction level. I believe there has been some work lately done, I believe in Python 3. What's currently being worked on, where some of the error messages look a lot improved, so that goes in the direction of making things more consistent. Also, objects, you can always use dunder-dict, right, to turn an object into, like look into an object in the form of a dictionary and forget about what the object is supposed to represent and stop reasoning about the object as the object it is, or the class it is, but look at it under the hood as a dictionary. Yeah, that happens, but you can deal with it. It's quite pragmatic, sort of thing. Also, I did not want to go into details here for time reasons, but some of the Python gotchas have, I think, to do with how abstractions work. The famous mutable default function argument gotcha, if you have encountered it, you know what I mean. If not, look it up. It means basically if you have a function and the function has arguments and you set default arguments with argument equals something and the something is a mutable object, you may not get what you expect because it is not limited to the scope of the function and gets reinitialized every time. You sort of get yourself a hidden thing that almost works like a global object, and it's probably the only gotcha I've personally encountered in the wild, like my own code failed because of it. So you think of it, why does it have to do with abstraction? It has to do with abstraction because you think of a default argument as something that's inside the function and doesn't have a life outside the function. It does, unfortunately. So, and then the performance warning that we got in the quote I had from the Python FAQ. Abstraction, simplicity, performance chose 2, basically. If you really want to design your abstractions so that they fit your real-world problem 100%, you will probably get a performance hit. I saw there are some great people to follow on Twitter. I saw, my mind gets blank, I forgot who it was, who just said, well, there is a dunder slots thing you can use to improve performance. So yeah, so there are ways around this though in Python, and specifically if you use Python for science, you get actually a lot of optimized things within NumPy. You get extensions to it that make performance faster, so Python isn't even so slow anymore. But be aware of it. It's not the solution to all problems, and sometimes you want to have a simpler thing that is a less elaborate abstraction level. Yep, so thank you. This is what I wanted to tell you, and I hope you had fun with it.
feels good right now after what we just experienced, doesn't it? Grilling out, lawns being mowed, and pools opening. These are some of the things we expect with summer.
So our next speaker here is Abhishek Kapatkar. He comes to us from Netflix, where he is a ML platform person, and he's going to be talking to us about a new language that we might be interested in learning about, NIM. So everybody put your hands together for Abhishek.
Can everyone hear me okay? Perfect. Have you ever wondered if there existed a language that's as fast as C, as expressive as Python, and as extensible as Lisp. If you have, then this talk is for you. My name is Abhishek. I am a software engineer at Netflix, and I'm based out in San Francisco. So the purpose of my talk is to give a quick introduction to NIM programming language, and then at a high level compare similarities and differences between Python and NIM, and then dive deep into some of the language NIM's merit. What makes NIM unique? What makes it exciting? What makes it productive? And why we as a Python developer should learn NIM. Let's get started. So what is NIM? NIM is an incredibly fast systems and applications programming language that's expressive, it's extensible, and it's really fun to use. Who develops NIM? Volunteers. Like Python, NIM is developed by volunteers. And over time, it has matured very nicely. And it has been actively under development since 2008. But in the last few years, it has been able to create a momentum and attract some really amazing developers and build a community that is passionate, dedicated, and is helping shape the future of the language. And it's licensed under MIT. Why learn a new programming language? I mean, learning a new programming language is really hard. It requires time commitment. It requires you to learn a new syntax. It requires you to learn new language semantics. It needs you to learn a new standard library, language quirks, and so many other things that goes in learning a language and being productive at it. So a language needs to be designed with clear and well-defined goals that will attract users to solve some real-world problems. And here are some NIM's design goals. It's built to be efficient, it's built to be expressive, and it's built to be elegant. So let's compare NIM and Python. But before we even get started, at a very high level, how is NIM different than Python? NIM is a statically typed compiled language. So you as a user is going to write NIM code, and the NIM compiler is going to take your code and convert that to C, and then feed that C to a C compiler to produce an efficient binary. And some other key differences and similarities is that NIM has a automatic or a manual memory management. It is a statically typed language. It has generic support. It has a minimal object-oriented support. It supports closures and function overload, and the distribution is binary. So this is very important because when you have a Python code and you want users to use your Python code, they need to have CPython installed. Whereas with NIM, you don't really need any runtime. You just ship a binary, and the only real dependency is a C standard library, which is available in almost all operating systems that are out there. It has support for multi-threading, and performance of NIM is similar to C and C++ because NIM compiler is going to produce a very optimized C code, which is going to run fast than Python. So here are my 4 top reasons why we should learn NIM. Expressive, clean syntax. So this is an area where NIM borrows almost entirely from Python. It uses a syntax that we Python developers are very familiar with. It uses white space indentation, it uses the same keywords, it has a similar control structure, and it lets users write easy to read, high performance code. As you can see over here, even if you don't know anything about the NIM, you can easily reason what's happening in this code. Another nifty feature in NIM is something called as universal function call syntax. So what this does is this lets user invoke function using method syntax call. So instead of writing a nested function calls, you could chain it and make your code a much more readable and expressive. It has a very simple and intuitive type system. So you can easily define a user-defined type system and then perform some operations on it, then instantiate an object, and then call the method on it. It also supports operator overloading. What this does is it lets you implement or change the behavior of your operator based on the arguments you pass to it. So you can perform operations on complex data type in a more natural way. So over here, I'm defining a tuple, and then over here, I'm instantiating two tuple objects, and then just performing addition on those tuples. Oops. Metaprogramming. So metaprogramming is a feature in NIM that lets you treat your application code as data. So you can pass your code to function to modify it, to analyze it, to generate additional code from the code that you just passed in. And this metaprogramming is very critical and useful for reducing the boilerplate, as well as making your code more readable, as well as let users define their own domain-specific language. So two ways NIM achieves metaprogramming is via templates and via macros. So templates are simple code substitution. You can invoke a template similar to a function or a procedure, and templates are declarative. So say you have a template which takes in x and y and performs multiplication. And then you invoke, and then you write code to invoke that template. And then during compile time, that template gets rewritten as echo 2 into 3. So this avoids a runtime overhead of doing function call. So you can use template not only to organize your code, but also to make your code execute at compile time and save some performance overhead that you get when you run a function during runtime. Macros are another way where you can perform advanced compile time code transformation. So it lets you take NIM code and then transform that code into another type of code. So it also helps you to reduce boilerplate, and macros are procedurals. So in templates, which perform simple code substitution, whereas in macros, you have to actually write code to generate other code. NIM is efficient. So the speed and the efficiency of the NIM primarily comes from the fact that it compiles to C, and then it takes advantage of NIM. It takes advantage of C compiler and C optimization techniques to run fast. It also has this very nifty feature called as compile time function evaluation. If you have a function whose parameters are known at compile time and has no runtime dependency, then you can actually evaluate that function at compile time rather than runtime. It also helps you reduce and produce compact binaries, which could be useful in a memory-constrained environments like microprocessor or your Raspberry Pi. It also has controlled garbage collector. So since NIM provides both garbage collection, you can turn it off if you want, and you have a full control over when you can run your garbage collector. You can choose between different options that NIM provides, or you can completely disable garbage collector. And this is really helpful when you're doing game development, for example. Cross-platform. So NIM's compiler can emit both C, C++, as well as JavaScript. It also lets you compile and produce final binary that targets different operating systems. Or you can just distribute your source code and let your client produce a binary depending on what OS they are using. So let's just go through some examples that will give you a concrete idea of what I've been talking so far. So here is a VS Code. On the left-hand side, you see a Python code, and on the right side, you are seeing NIM code. As you can see with these basic examples, you have all the usual things that we are expected in a Python. We have lists, we have dictionaries, we have data types that we are familiar with, and NIM provides you with an equivalent alternative. So over here, you can see you are importing certain modules, you are defining your main function, then you are defining all the data types. Over here on line 15, you have a name tuple, and NIM provides you a way to also define a NIM tuple. You have class, you have object, and then here you are instantiating a person object, same way in NIM. Let me quickly go to everyone's favorite, Fibonacci. So here you are, like two codes side by side. It's same line of code, but the only difference over here is like the one that you see on the right is going to run an order of magnitude faster than the one you see on the left. Let's try to run this code. As you can see, it took around 4 seconds to run a simple Fibonacci number. Let's just see how it is. Oh. So as you can see, it's an order of magnitude faster. The other cool thing is that if you want to inspect, you can see the C code that it got generated for the Fibonacci. So if you're coming from a C, C++ background, you will find this really interesting, and you can then perform more deeper analysis and make your code even more faster if you are really familiar with how C works. Let's take another example. That will give you a little bit idea of like high-level data structures that this provides. So over here, you are defining a class. You have your init, and then you're defining two methods. The equivalent in NIM is like you are going to define an object, and then you're defining two procedures. And then you are invoking that using square.area and then square.parameter. Because of universal call function syntax, square.area is nothing but invoking a function called as area and passing square to it. So as you can see, the syntax and the ease of how you can express the problem, solution to a problem is very similar in both languages. So what are some other language features? So NIM is self-hosted. That means NIM's compiler is written in NIM. Sometimes it's very easy to just go deeper into behind the scene and see what's happening. There is no GIL. It has a very intuitive foreign function interface. So you can interface to any C, C++ library that's out there because NIM compiles to C. So calling C functions is very easy in NIM. It also has async await. It comes with a package manager as well as a documentation generator. So what are some real-world use cases where you can use NIM? Because of a friendly, easy-to-reason syntax, its compilation to C, C++, and a very rich standard library, NIM can be used for building a very diverse set of systems and applications. I have seen, and I have linked to the code repositories where people have used NIM to build web services, APIs. You can really build command line applications, so you can ship a binary so that users don't have to worry about installation. You can write compilers. It's really useful for scientific computing because of niceties it provides, like operator overloading, universal function call syntax, and its compilation to C, C++. And it's also very easy and efficient to write games in it because you have full control over garbage collector. And it can be used as a scripting language because as you saw, like compiling a NIM script, a NIM code was very similar in terms of execution speed as well as how fast it was to run it. And because of its JavaScript compilation, you can also build web applications using NIM. And one practical usage is like instead of writing C directly, you can just use NIM code to produce C, and then you can call that C from your Python. So here are some other project showcases that showcases some of the powerful features that I just talked about in NIM. So yes, NIM is refreshing. It takes a unique approach towards achieving distribution and speed, but there are some reasons why convincing your teammates to use NIM can be challenging. The first one is, of course, it has a small ecosystem. Python has taken a lot of time, and we all have come to Python only when it has demonstrated value to us. So it's going to take time for NIM to create that kind of ecosystem where the value that it delivers is clear. And compiler is still not perfect. No compilers are perfect, but there are occasional bugs in NIM's compiler which can be a little nasty. And here are some links on how you can get started on NIM in terms of deep dive. In summary, NIM's language goals are based on these three pillars: efficiency, expressiveness, and elegance. I hope you found the similarity and the correlation between Python and NIM interesting. It has a Python look and feel. It can produce zero dependency binaries, and it has a very comprehensive standard library. I hope you can take, like how I felt, like I was able to take my Python knowledge and skills and overlay it on top of NIM, and I was able to solve some really interesting and fun problems using NIM. So since I have like a couple of more minutes, let me show you one more example. So the Fibonacci number that I compiled, let me compile it to JavaScript. So here, what I'm telling NIM is like, hey, NIM, take my Fibonacci NIM code and produce a JavaScript output and then run it. Or I can just directly invoke using Node, and I can just directly give it a JavaScript file, and then it produces the same thing. Since we have a few more minutes, so this is a game built by NIM's core developer. Here you have so he wrote this game in NIM and then compiled it to a JavaScript, and then you can just play it. One last example, there's this amazing person based in San Francisco. He was able to use NIM to build a thermostat, like a Nest-like thermostat for his home with his kid. So you can read, so he has a short presentation on the whole entire experience that will give you even more idea about all the features that I talked about in NIM. Yeah, thank you.
Hi, welcome back. So we're gonna get started with our next talk. Our next two speakers are Philip James and Ashish Laroya. Philip works in software in San Francisco, and Ashish is a systems engineer at Reduct, and they'll be telling us about account security for the fashionable app developer. Please welcome our speakers.
Cool, great. Can everyone hear me okay? I'm getting some like hand waves. Okay, great, perfect. Ashish, will you permit me a bit of silliness we haven't done before?
Yeah, what's going to happen?
Great, come here.
I actually don't know what's
Come
going to
here.
happen.
Yeah, this is great. We're going to do a speaker selfie, which is something I've always wanted to do, but never actually gotten around to doing.
Where am I supposed to be?
Over here.
Okay.
Okay, right? Okay, everybody say cheese.
Cheese. Wait, who was photobombing it?
I was going to have everybody shout security, but I realized that might be bad. Building management might get confused. So cheese seemed like a safer option.
All right.
Hi, my name is Philip James. I lead the platform team at Patreon in San Francisco. I've given a number of talks about security over the years. I've worked adjacent to security teams for a number of years, and I really am passionate about keeping systems safe and building them to be user-friendly at the same time.
My name's Ashish. I am a systems engineer at Reduct, which is a tiny 7-person startup where therefore the small engineering team does everything. In the past, I've worked at Eventbrite as a security engineer, and I love paying attention to this stuff.
So we like giving talks together. These are some of the talks that we've given together and separately. Right now, what you need to know is that we have worked on a lot of websites. We've worked on a lot of web applications in Python. We've worked on backend API infrastructure in Python. Some of the things we've worked on have been good. Some of them haven't been so good. We've spent a number of years trying to stay on top of the best account security practices, and we know we've done it badly. This is kind of a letter to our past selves that you all get to enjoy with us. So I'm going to start with some bad news. I'm sorry to start on a bad note. People who use your website are going to lose control of their accounts. Gonna happen. And it's probably going to end up being your problem when they do. So let me define losing control of an account. If Ashish here has an account on your website and someone else can log into it without Ashish's permission, something has gone wrong. If Ashish permits someone else to use his account, that's out of scope for this talk. With that said, account security is all the techniques that go into making sure Ashish is the only one who can access his account on your website. We're going to focus on techniques that relate to that specifically. You're going to have to make sure that your app doesn't have other really big problems like remote code execution or cross-site request forgery or whatever else.
And if you want to learn more about those topics, you can look at the Django security tutorial that Philip and I and another friend gave at PyCon a few years ago.
Yep. By the way, that down at the bottom, hopefully those are somewhat legible, are our Twitter handles, and there's the PyCascades hashtag, doesn't say 2019. Oh well. If you learn something or you want to talk to us about these things, feel free to tweet at us, and we will respond to them after the talk probably. So yeah, account security. We want you to get 3 big pieces of advice from this talk. Make it costly to take over an account, help your users stay informed about potential account takeovers, and empower your users to defend themselves when an account takeover might be happening. The reason to do these things is that it's a pretty scary internet out there, and your users know this. The amazing thing about this montage, if you're looking carefully, because we did, each of these breaches happened in the past year. This is just like the headlines of the past year of account breaches, and all of them had something to do with account security information. Each of these breaches makes it more likely that a user's account on your site is going to get breached because we know that users are pretty likely to reuse both email addresses and passwords on their sites. So the main thing you can do to protect your users is to make it hard for other people to take over their accounts. And Ashish is going to start by talking about passwords specifically.
So I put here a list of the most popular passwords. Literally, like, I'm not kidding. These come from breaches. A research team went and just sorted, and these are the top ones. And if your users use 12345 as their password, or 123456, their account is practically public. Somehow it's still a really popular password. So to avoid these kinds of passwords, security people created the idea of password rules. So here's some special characters, here's some numbers. The most common rules are inspired by a publication from the National Institute of Standards and Technology from 2003. And I recently read an interview with the guy who wrote that publication. Not joking. Literally Bill Burr's words, he's sorry. He was on a tight deadline in 2003, and he published a bunch of advice, which, we know how he feels about it. It's okay, we can all get past that advice. There are new rules from NIST, published in the past couple of years, and they focus on the importance of making sure your users aren't using common passwords on your site. My favorite way to do that is to use a JavaScript library published by Dropbox. So here are 3 screenshots of the account creation form on the Python package index. PyPI, warehouse, cheese shop, same thing. And in the form, I've entered 3 of the most popular passwords, and you can see that despite ABC123 having letters and numbers, it's still red password strength, and that's because it's a very common password. PyPI is using Dropbox's open source library called ZXCVBN, which, has anyone detected the joke in the name here? Okay, so it's ASDF moved down a row on the keyboard. I didn't until I read the docs. That thing checks if the password is in the most popular 30,000 passwords. It's written in JavaScript so that you can run it in the user's browser before they even send you the bad password. They're stopped and they'll change it. There are some other goodies in that new NIST publication. I really recommend searching for it and reading it, but the most important aspect in it is to ask users to use uncommon passwords. ZXCVBN can help in the JavaScript front end, and I also want to talk about checking that on the Python backend. So Troy Hunt runs a free website and API called haveibeenpwned or haveibeenowned.com. He publishes a list of SHA-1 hashes of passwords that he has founded in breached websites, along with the email addresses of the accounts involved. And there's an email input right there. This is a real website. If you're lucky, your users are typing their email address into this thing and checking for themselves periodically. But chances are they are not. There's also a really good chance that they're using the same password on one site that got breached, I see some nodding heads, as they want to use on your site. Since Troy only publishes SHA-1 hashes of passwords, you can't loop over his database and check for those passwords in your database because of the way password hashing works usually. I will show you something you can do. You can send the raw password, so when the user is trying to log into your site, you have the password they're using, and same with when they're setting up their account for the first time. You can send that to the haveibeenpwned API. They make a privacy-conscious API where you send the first 5 characters of the SHA-1 hash of the password, and they respond with the full SHA hashes of the password. All the passwords that match that have showed up in breaches. And if you don't want to query an API, you can download the full list from them. It's about 11 gigabytes compressed. By the way, I hear some chuckling. PyPI and other sites do use this haveibeenowned API. I will say that Django has a built-in user system that solves the same problem in a different way offline. Django bundles, as of the most recent version, as of 2.1, a list of the top 30,000 passwords. And so it checks against those when an account gets created. If you do want to use the haveibeenowned API, there are 2 options for integrating with Python, for integrating with Django. So here they are, both published by people whose names are kind of like James. Okay. And a third thing you can do is to read the source code to the Python package index. The Python package index uses Pyramid, and so they integrate directly with the haveibeenpwned API. You can read that. It's pretty easy reading. Strong passwords are an important aspect of account security, but they're only one factor. You can add more factors for more account security, and Philip will tell you about that.
If I were in a caption contest, I would say, this is a picture of two-factor authentication. You all probably know this. You all probably use it for some of your accounts already. Multi-factor authentication is the thing where you as the developer can insist people use something in addition to their password to log in, typically a phone. I'm going to talk about different ways people set up multi-factor authentication to hopefully encourage you to do it for your site. But before I proceed, I want to say how phishing relates to multi-factor authentication. Most MFA schemes are phishable. You're adding another factor, but you're not making it phishing-proof. There are some techniques we're going to be talking about later on that decrease the chance of phishing, but MFA is not a phishing panacea. You still need to be thinking about those kinds of attacks. The two main ways people set up MFA is through SMS or with an app. With SMS, you send them a short-term code, and they type it into your website. SMS is not free of cost to send, however, and if you're looking for a solution that you as the developer can implement more easily and perhaps more cheaply to you, you can use something like Google Authenticator. This is Google Authenticator. How many of you are using Google Authenticator or some app like it right now? Wow. Awesome, fantastic. Great, now keep your hands up if you've set up an integration with Google Authenticator. Wow. More hands than we were expecting, but still a lot less hands than the people using it. So that's okay. There are definitely packages that can help you that we'll be talking about later. But the big thing to know is that app-based MFA like this is really just your server and your user's device agreeing on what number is going to be valid at what time. The app can generate the number as the server, therefore no need to send an SMS. So that's pretty good. If you have users who want two-factor security, then you can set this up for them and not pay anything to Twilio. Sorry, Twilio. There's something else you can support for free as well. This is a picture of a YubiKey. How many people have a YubiKey? Wow, great. How many people have set up U2F for their service? Okay, yeah, that's the number of hands we were expecting. YubiKey supports a standard called U2F, or Universal Second Factor. I bring it up because it's an alternative to asking people to pull out their phones and either get texted or open an app. Since implementing keys like YubiKeys internally, Google has eliminated corporate account takeover. The main thing to know about U2F is that the browser sends the domain name to the U2F device, and therefore it's much harder to phish than other SMS MFA or password-based authentication mechanisms. Setting up U2F does involve creating a certificate, so it's a bit more hassle than other forms of MFA, but it's still probably worthwhile and offering for your users. They do have to buy a token, but you can also just mail them one, kind of up to your security model. At this point, I'm just going to give you a list of resources. So there's multiple excellent sponsors here who would love to help you get it set up with SMS MFA, if that's what you want to be doing. You can also use TOTP as the name of the spec that helps generate the codes, Google Authenticator, et cetera. There's a Python library for that. And there's a Python library for doing U2F. So all of these things are totally doable for your site. Two-factor authentication is one way to secure accounts, even if the password isn't super secure. But Ashish is going to talk about a whole other way of logging into accounts that makes the password less relevant.
So here's how Slack asks me to log in. I get an email, I click a link, the app finds a token, Slack finds a token in the URL that I clicked, and now I find myself logged in. How many of you have used this mechanism on Slack? Cool. Do you like it? Wow, I see some mixed reviews. Okay, great. So Slack is betting anyway that users and the user's email provider care more about their email account than their Slack passwords. And Slack is really leaning on email account providers to help prevent account takeovers. For all the Slack users with Gmail accounts, Slack is asking Google to be the first line of protection to prevent Slack account takeovers. So Slack is really betting that the Google account security team is pretty good at protecting Gmail. And that's a pretty good bet for you to make too if you want with your app. So to me, this fits into the pattern of making it as costly as possible to take over an account. The attacker's cost for a Gmail user now includes the cost of breaking into Gmail, which is presumably quite difficult. Slack does also have a username and password login scheme, and I actually think they don't want me to use it. They really seem to push me toward this, and I think that's because Slack really benefits from knowing that when I'm logging in, I'm in control of my email account at the same time. So I'll talk briefly about how to implement something like this. So if you use Django, there's a Django package that does this for you. It's called Django TokenOff. And if you want to implement it yourself, you need to store a random token in your database. At Sandstorm, a company I used to work at, we used a slight variant of that, which is we store the hash of the token in our database. That way, this gives you one useful thing, which is that if somebody manages to steal your entire database, they can't also go log into all the accounts on your server using what they've stolen, which is like a, that wouldn't be great, but it helps a little. One thing to know about data storage, these are random tokens. They're not going to index well in a database. Databases try to use cool tricks to shrink the index. You're going to end up with a database table whose index is the same size as the table itself. And by the way, so I saw some resistance to the Slack login thing from somebody. Personally, when I first saw this, thought it was weird and insecure. And then I realized it's basically the same as doing a password reset. Those also get sent out by email. And most users, by and large, have pretty bad passwords. It's true. Mine are okay at most sites. I use a password manager, but you can't bet on that for your users. So we could say a lot more about making it costly to take over accounts, but there's other aspects of account security we want to talk about as well.
So once you've done the first pass on making accounts hard to take over, your next step is to help your users help themselves. You can do all sorts of things to make it difficult for someone to take over an account, but the person who really knows if an account has been taken over is the person who created the account. So give them the tools to help you know when something is wrong. This section could also be called building trust in your users, because a lot of these patterns are actually things you can do to signal to your users that you've got their backs, that you are paying attention and watching out for their accounts, and they have seen all of the breaches that we showed at the beginning. Your users probably have security nihilism. They expect their account to be taken over, and anything you can do to help them build trust reflects better on you as the app maintainer and makes it less likely that their account will be taken over and stay taken over. How many of you have seen one of these before? Notification from Facebook? Yeah, great. Facebook and Google are really good at proactively letting the user know when something weird has happened with their account. They both use email login notifications like the ones pictured here, and in some cases use their in-app notification system to let the user know that something has happened. When I get notifications like this, what I feel is a big ball of trust from Google or Facebook that they're paying attention to what's going on with my account. You can share this warm ball of trust with your users pretty easily, it turns out, and fight back some of the security nihilism. If you've paid very close attention to Google and Facebook's security practices over the years, you'll see they don't always send you a notification because they have big machine learning data science teams that can detect the right time to send a notification. But you probably don't need all of that to provide this first level of information to your users. You could say, save the user's last accessed IP address or geolocation, and then send them an email if that changes. Here's some code that might get this done for Django. We're using the Django signals framework here. We're listening for the user logged in signal. And if the user's last IP, which we've saved on a table somewhere, doesn't match the current request IP, send them a login notification. Let them know, hey, you got a new login on your account. Did you expect for this to happen? The cool thing about this is once you have this set up, you can continue to tweak the rules until you're not delivering so many notifications that it's bothersome to your users. Additionally, you can use code like this to send them an in-app notification if you're using something like Django's messages framework. This will do, at the same point, add a message to the messages framework that you can then render the next time the user loads a page and be like, hey, by the way, we detected this weird login notification. Did you mean for this to happen? If you go a tiny step further and spin up a table for storing session information, or use Django's sessions table feature, you can now build one of the systems like Google or Facebook that shows you the list of actively logged in sessions and help your users be informed about who's using their account. Once you've unlocked the power of comparing information about logins and sessions, the world is your oyster. And there's a more advanced technique that Ashish is going to talk about now.
So the pattern we've just implemented can be used for all sorts of events your users would like to know about. Like for instance, password changes. If an attacker broke into a user's account and changed the password, it's going to be really important for the actual user to get that problem resolved fast. Since we still live in an age where there's no universal replacement for passwords, you as the app maintainer should do everything you can to let your users know when the app password has changed. Slack-style email login makes passwords less important, which is good, but it doesn't prevent you from needing to control the user's password and letting them know when it's changed. So I'll show you one way to do that. Here's some sample code in something like Django. This is a subclass of the user model. You could apply this to any other framework too. The key thing we're doing here is that when the user model is instantiated, we store a copy of the password so that then later, when in the same request, the save method gets called, if it does, we can compare the user's current password that we've stored in the model, in the class instance, against what's being saved now. And then we can send them an email. So as an aside, here's a picture of mint.com asking me for my bank password. I bring this up because if you build a useful website, others might want to integrate with it, and users are going to hand out their passwords if you're not careful. This is why people make OAuth APIs, so that a user can hand over an API token instead. If the API token gets compromised, it's easy enough for a user to revoke it, or you can do that yourself.
So the most advanced technique that we're going to talk about for the keeping your users informed section is notifications about other breaches. You can notify users about breaches you detect in general, even if they aren't necessarily related to your site. Remember all these breaches? Troy Hunt's Have I Been Pwned database has all of them. In fact, that's where we got these screenshots. And it includes the email address for any accounts that have been breached. There's a thing you can do with those emails, which is potentially send your users a notification when their email is detected in another breach, because as we said, the odds that they're using the same password for your website and the breached website is very high. This is an email from Credit Karma that they sent that doesn't look very happy, but is also kind of like, cheerful, modern colors and a cute little icon. You can do something like this and make it very clear to your users that, hey, the breach was found in another site. This is the riskiest technique because it can backfire. It's the best thing you can do to keep your users informed because they aren't going to be going into Have I Been Pwned themselves, but they could misinterpret your email and have it read as, oh, your site was breached. So if you're going to do this and you have access to your communications or legal team, run it by them once first before starting to send these out.
Ask Philip in the Q&A later why he said that.
No reason. So we've talked about a few ways to present information to your users to help them know what's going on with their accounts, but we want to close with some specific ways you can help them act on that information.
So here's a picture of what it looks like when I change my Facebook password. We talked earlier about the possibility of showing a list of sessions where I'm logged in, sessions of where the user is logged in to the user. Facebook, you can see here, gives you the option of logging out the other devices. This feature can be hard to implement, and users might not go looking for it. So there's a simpler approach I want to tell you all about. If a user changes their password, they might be worried someone else has the old password. So it can be a good idea to log the attacker out. So in 2012, Durley Rodriguez asked on the Django user mailing list how to implement that, how to invalidate active sessions after a password change. There was no built-in feature, so Durley implemented it himself. And later on, a fellow named Albert implemented a reusable app that accomplishes the same thing. And in Django 1.7, Tim Graham implemented this feature using the same algorithm that Albert and Durley used. The idea is to store a HMAC of the user's password in the session, and that way, when the user changes their password, you can check the session data. No. That way, when a user logs in, you can see if the HMAC of the password is still the same as it used to be. It allows Django to invalidate previous sessions without being able to query them, because the hash password is stored in the session. So being able to change session data is a pretty powerful tool. And there's one more technique I want to show you about. First, I'll ask you a question. How many people here are logged into GitHub right now? I know I am. Great. And how many people ever remember logging out of GitHub intentionally?
Like once, maybe?
Yeah, so not as many people. I said we want to try to limit the damage when an account is compromised. And if a user lets a friend use their laptop and the friend visits GitHub, you might wonder how much damage they can do. So here's a picture of GitHub's feature called sudo mode. They ask you for your password again when you're doing something sensitive, like adding a new SSH key. I want to talk very briefly about how to implement this. So if you have a Django view that does something dangerous, maybe upgrading the user's account, here might be some code for it. It requires the user's logged in. It requires a post. It'll look at the user's payment plan and upgrade it. And what we can do is check for a thing that we'll call sudo mode with a magical decorator that I'll explain how it's implemented. What we will do is check the session for when the user most recently logged in. And if it's not recently, then we show them a message that looks like this. You might need a URL. This will have a URL. It'll look something like this. You could make the message customizable so that the user can, so that you, the developer, can swap out the word upgrade in the URL, and it'll swap out the word upgrade there. You might want to have a whitelist of those. And here's some quick pseudocode for it. I will tell you that Django there's a Django app called Elevate that can do this for you.
So the reason you might do something like sudo mode is you don't trust your users to log out. There is a permanent logout, however. And a funny thing about popular websites is that people start asking for their accounts to be deleted. It can fill up your support queue, in fact. Sometimes people want their personal data to be visible online in fewer places. Other people want to know no one is going to break into their account. Whatever the reason, if an account is deleted, that's pretty secure. You don't have to hard delete the data, depending on your jurisdiction and some GDPR stuff. If no one on the internet can log into the account with its correct username and passwords, that's pretty good. And so I guess we'll close by saying that the absolute best way to secure an account is to not have the account at all. These are the big 3 points. If you remember these, hopefully this will help you inform your own approaches and make the rest of the talk make sense. Make it costly, help users stay informed, empower users to defend themselves, and I think that wraps it up for us.
Yeah.
Come find us afterwards if you want to talk about this stuff more.
The next talk starts at 5:10.
Luckily, you get a chance.
To a cloud, up a tree, clinging to a cloud, up a tree, clinging to a cloud, up a tree, clinging to a cloud.
What we do here is go back.
Talk, we have Trey Hunter, who's going to tell us about meaningful mentoring moments. Welcome, Trey.
Thank you. So, I help developers level up their Python skills. I do that in 2 ways. So I run a weekly Python skill building service called Python Morsels. A lot of you have probably found stickers for this around the venue. I also do on-site training for teams to help them level up their Python skills. I'm going to be talking about some of the things that I've learned while doing that second thing, while doing training with teams. I'm also going to be drawing actually pretty heavily from experience that I had before I was ever doing training, coaching at programming workshops. Some of those include Django Girls workshops. So I've coached at a couple of Django Girls workshops, and I've also meta-coached and acted as kind of a coach's coach, in a sense, at some Django Girls workshops in San Diego that I've helped organize. When it comes to coaching, mentoring, teaching, this whole kind of area of topics, I often don't really feel like I know what I'm doing, but I do feel like I'm qualified enough to talk about some of the things that I've learned through this process. So that's what we're going to be talking about here. So show of hands, who's coached at a Django Girls workshop before? Who's coached at any other programming workshop, including a Django Girls workshop? Keep your hands up. Who has sat next to someone at work, maybe a new hire, and helped them with their code? All right, so that was a lot more hands. So for those of you who didn't raise your hands, I'm hoping in the future you can, if you end up in a similar situation where you're sitting next to someone helping them with their code, you may find this talk useful. So we're going to talk about a very specific scenario. You are sitting next to someone and they need your help with their code. But they don't just want you to fix their code, they want you to help them improve their coding skills. So this relationship that you have here with this person, it might be a longer term relationship. We're going to assume this might be a temporary relationship though. We're going to be focused on the in the moment relationship we have right now. Something I won't be talking about is Python. I'm not going to be talking about Python or programming. This is the first talk, in fact, that I've given where there will be no code on the slides, which is kind of weird for me because that's the thing I usually teach. But that's what we're talking about. So I am going to be talking a little bit about teaching itself, kind of teaching learning theory, but really not very much. And as odd as it might sound, this talk, it's called Meaningful Mentoring Moments. I'm not really going to talk about mentoring. What I am going to be talking about is something that is related to mentoring. Some people call mentoring. So mentoring in the way that some folks use the term, Kim Creighton, for example, gives a lot of talks on mentoring. It's a big picture, longer term relationship. You're not necessarily just talking about code. You're talking about goals in a bigger sense of the word. We're going to be focused instead on something that's smaller picture. We're focused on helping in the moment. So really this is more like coaching, which is what Django Girls actually calls this in their curriculum. So there are 3 big topics that I want to discuss. The first one is being an ally in learning. So when you're coaching someone, I don't want you to be an expert. I want you to be an ally because you're not the star of the show. You are a side character here. Your job is to support and guide the person who you are helping through this learning process. They shouldn't be dependent upon you. The process is centered on them, not on you. So I often live code when I teach, and when I live code, I'm always tempted to write out some code and then explain what that code is doing. That is not teaching, it's telling. I don't want you to teach. Sorry, I don't want you to tell. I do want you to teach. So you can do this. You can focus on teaching and not on telling by actively encouraging active recall. So that's the idea that you're retrieving something from your head. You're retrieving information that might be in your head already from it. We don't learn by putting information into our heads. We learn by trying to take information out of our heads, by trying to retrieve information from our heads. It's not putting it in that's the learning process, it's taking it out. So who has heard the phrase, you learn by doing? So you learn by doing, that everyone's heard this phrase before. It's true, you learn by doing, but the reason we learn by doing is we're retrieving. It's the act of retrieval that's the process of doing. Now, the tricky thing here is that the doing is the hard part. That's the most intimidating part when you don't know what you're doing. But that's the way you learn. The way you learn is doing this intimidating thing, which is the doing. So you can help your learner by encouraging them to make mistakes. So making mistakes, it involves a process of considering what might be a correct answer, what isn't a correct answer, and trying it out. You're failing, you're trying again, you're failing, you're trying again. This is a learning process. Now, I don't just want you to set aside a space where making mistakes is okay. I want you to actively encourage making mistakes. So what I mean by this is you could, for example, say, when asked a question, I don't know, give it a try. You're basically saying here, let's make a mistake together. I don't know what we're doing, but let's make a mistake. Or, what have you tried so far? Which is another way of saying, what mistakes have you tried up to this point? What have you done that didn't work? So I want you to actively encourage your learners to make mistakes. After you've made mistakes, maybe you've made mistakes together, they will find themselves stuck at some point, inevitably. At that point, I want you to not answer any questions. I'm kidding, you actually do need to answer questions. Answering questions is important. This is a learning process. You need to facilitate learning. I do want you to be careful, though, when you're answering questions, you're going to need to remember that you shouldn't be telling, you should be teaching. So you don't want to just give all of the answers in this process. So when you answer questions, you want your answers to be sticky. So you could make an analogy, for example. Analogies are really sticky. Bad analogies especially can be very sticky. Memorable moments are sticky moments. So for example, if you came up with a dance that demonstrates the way dictionaries work in Python, I don't know what that dance would look like. I'm not going to do it because I don't know what it would be, but if you had a dance like that, you could do that dance. It would be a memorable moment probably. It would be sticky. So make your answers sticky. And when possible, when you're giving answers, it's nice to actually avoid being the source of the information, to not give the answer directly, but to go on a learning adventure together. So you can do that by pointing your learner in the right direction, by delegating to the documentation, looking something up together, or more realistically, delegating to Google. So if you're sitting next to someone, who you are coaching, and they ask, why am I getting this error message? Instead of saying, I know the answer to this, you could say, let's look it up together. You might know the answer, but looking up the answer in another source of information is a good idea because you are a resource, you're not the only resource. You want to delegate to resources that are available at 2 in the morning or over the weekend when probably you don't want your learner to call you and use your time. So making mistakes together is important, looking things up together is important. Sometimes you really just need to talk things out though, to talk through a problem together. When you're walking through a problem together, I want you to take some inspiration from a friend of mine. This friend here, or actually these friends here are fine too. Also these ones. These ones are good as well, and so are these. Any of these are great. Who's heard of rubber duck debugging before? So rubber duck debugging, that's actually quite a few of you. What this is the idea that if you get stuck on a programming problem, you talk to your rubber duck. Your rubber duck doesn't talk back, at least hopefully it doesn't talk back. It's not supposed to. It doesn't know the answer. You're talking through the problem with your rubber duck to try to uncover things that you hadn't thought of yet. You're elaborating with your rubber duck. So I want you to not be silent like a rubber duck, but I want you to do a lot more listening. So for example, if your learner says, my code doesn't work, you could ask what they expect the code to do and what it does instead. When they tell you that, you could then ask them to let you know what the approach that they're taking is, to talk more through the problem with you. So less talking, more listening on your part. Elaboration is a really great way to learn. That's what rubber duck debugging is really about, and you can help them with elaboration by kind of being a rubber duck in a way. So teach, don't tell. Actively encourage making mistakes and try to act sort of like a rubber duck, maybe a Socratic rubber duck. You're going to be encouraging questions. You're going to be listening, but you're not going to be speaking so much there. And delegate to other sources of information because you are not the star of the show. The spotlight shouldn't be on you. Your learner is the star of the show here. So being a learning ally is important, but this is not just an intellectual pursuit. Learning is not just an intellectual pursuit, it's an emotional experience. It's going to be emotional for your learner. It maybe will be emotional for you as well. Who remembers learning a new technology and you felt completely and totally lost? Yeah, so that's pretty much everybody. So your learner is going to be living that moment. Maybe not all the time, but probably a lot of the time. This is going to be a vulnerable experience for them because they're going to be displaying their lack of knowledge to you all the time if you're doing your job right. So it's important to build trust with your learner. Your learner needs to feel comfortable being vulnerable with you. They need to trust you. One big way to build trust is to be vulnerable yourself. So there are a lot of ways to make yourself more vulnerable, to kind of remove a bit of that automatic power balance between you and the person you're mentoring there. For example, I make bad jokes. They're not usually funny. I mean, that's usually why they're bad jokes, is they're not funny. But they make me more vulnerable because I'm making a joke that isn't very funny, and it kind of puts me on the spot there. I also make mistakes. Sometimes I make them on purpose. A lot of times I make them on accident as well, partly because I'm live coding, and you always make mistakes while you're doing that. When I make a mistake, though, even if it's on purpose, I never say, I did that to test you. Because why would I say that? I want my learners to feel my fallibility. That makes me a little bit more vulnerable. It helps them more than telling them that I'm doing it to test them would. Another big way to be vulnerable is to say, I don't know. So, for example, you can say, I don't know, let's try it out. Or, I'm not sure, let's look it up together. Delegating to other sources of information is great. Saying, I don't know, is important for building trust. So these are 3 ways to be more vulnerable. They're not the only ways, and being vulnerable is not also the only way to be more trusted. There are other ways to build trust. Another big factor in being trusted is considering the way that you speak. So here are 4 ways to ask almost the same thing. What does this do? What will happen when we run this? What do you think will happen when we run this? And what do you think will happen when we run this? What's your guess? These are very subtly different. We're asking the same question 4 different ways. Which of these do you think is the most welcoming? What's your guess? So I would say that last one is probably the most welcoming. The first 2 actually feel kind of like a pop quiz to me. You want to encourage active recall. You do want to quiz your learners. You don't want them to feel like they're being quizzed, though. There's no reason to add an intimidation factor. You want to invite your learners to guess and to make mistakes. Confident and assertive language has its place, but welcoming language is usually more appropriate when you're trying to coax answers out of people, when you're trying to encourage guessing. So I want you to think less about what you're saying and more about how you're saying it, how what you're saying might be actually heard. I want you to be encouraging while you speak. So there are a lot of ways to alienate your learner in big ways and small ways, kind of inadvertently. A lot of this is really in the way that you phrase things. So obviously, many things are not obvious when you're learning. In fact, probably the things that you're talking about are mostly the subject is not obvious there. Of course, this one's a little bit more subtle. When you're new to something, there are rarely of course situations. There's just not many of them. You'll get there at some point, but you're still learning. Oh, it's easy, you just. If it were easy, you wouldn't be doing it. You wouldn't be focusing on this learning moment. Something that's easy for you is not necessarily easy for your learner. What's in your head is not in the head of the person who you're mentoring there. So this next slide here, I think, is the scariest one in my talk. If you don't believe in your learner's ability to improve themselves, they're less likely to improve their own skills. Who has heard of the growth mindset before? So the growth mindset, the idea with this is if you adopt a growth mindset, you believe that through directed effort, you can improve your own skills. So your skills aren't fixed, they're expandable. If you adopt a growth mindset, you are more likely to grow your own skills. Believing that you can is something that actually makes it easier to, in fact, grow your skills. It is hard to believe in your own abilities if the person who's mentoring you or coaching you doesn't seem to believe in your abilities. So you need to give the person who you're mentoring, you're coaching, the impression, either explicitly or at least implicitly, the idea that you believe in them, that you believe in their ability to grow their own skills. So building trust involves being vulnerable, speaking deliberately, which involves making sure that you are encouraging and not alienating the person who you're working with, and believing in the ability that your learner has to learn, believing in their potential and their capacity to grow themselves. So to recap, you want to be a learning ally, not an expert. You don't want to be seen as the star of the show here. You also want to build trust with the person who you're mentoring. You want them to be more comfortable in being vulnerable with you. The last thing that I want to talk about is a way for you to improve your abilities, your mentoring abilities, as you go by kind of learning from yourself. The last thing that I'd like you to do is slow down. So I want you to slow down your thinking. I want you to slow down your speaking. I want you to slow down your actions, especially when you're in a situation where you're not quite sure how to act. Let's say your learner says, my code doesn't work. They show you their code, and you notice pretty quickly 4 things in their code. You notice a function that is improperly named. You notice code that's a little bit ugly, but it does work. You notice something that seems like a logical error, maybe a misunderstanding of the actual problem that you're solving. And you also notice a syntax error, something that's stopping the code from running at all. Which one of these do you focus on first? What do you think? So some of you are guessing here. This is kind of a trick question, actually. It's a trick question because you want to focus on the one that's hanging up your learner, which could vary. Now, probably that second thing is probably not hanging up your learner. If they have these 4 problems, they're probably not asking about code style. In fact, code style is often something you can just leave for another day. Talk about it at some point, but if you've got these 4 problems, this is not your top concern at all. Now, if it's not on code style, the thing that might be hanging them up that's most likely is probably that syntax error. That's probably the thing they're going to notice first because Python notices it first, so they're going to notice it, and then they're going to ask you about it. So the most important thing right now is the thing that you should focus on. You talk about the thing that's important in the moment, and then stop. You stop, and you wait, and at some point in the future, maybe you'll get asked questions about other things. You can have discussions there. You don't want to rush, though. You want to slow down. You're going to be better at knowing what to do next, what thing you should be focusing on next, if you can empathize with your learner, what they might be feeling. I want you to slow down and reflect. So when you speak, question what it is you're saying, why you're saying it, and how that might actually be heard, how your learner might be perceiving that. Now, reflecting on your actions in the moment can be really distracting. I don't want you to get hung up on constantly analyzing yourself and what it is that you're doing. But I do want you to find a way to kind of carve out some space every once in a while to kind of marinate on the moment that you've got and think about what it is that you're doing and why you're doing it, what you've just done, and where you might be going next. Reflection is a really important part of learning, and you are also learning. You're kind of learning together. Another thing that you might want to consider is learning about learning itself. So there are a lot of folks who write about learning best practices the same way that as developers, we tend to write about programming best practices. These best practices in learning are useful for you because you're learning, but they're also useful for you to maybe share with the person who is doing the learning, the mentee that you have there. So for example, you can talk about the growth mindset. You can also talk about the fact that you don't learn by putting information into your head, you learn by taking information out of your head. It's that retrieval that is learning. So this discussion about learning, it could just be a moment for you kind of regurgitating ideas that you've learned about learning, but it could also be a lifetime for the person you're working with there. These are very impactful things. If you're getting better at learning, you're also getting better at the skill of programming itself. Fake it until you make it. Who has heard this term before? So I think we've all heard this term. I don't really like this phrase. It sounds kind of weird to me, sort of insincere, demeaning. The connotation, it sounds off to me. There is some truth to this idea, though. Fake it until you make it, it's kind of another way of talking about adopting a growth mindset. So if you slow yourself down and you think, if I were a good mentor, what would I be doing right now? You're faking it. You're acting deliberately, you're pretending, but you're also practicing, which means you're learning. So eventually you won't have to be faking it so much. It won't feel like faking it as much because it'll be a little bit more intuitive. Faking it is a way of growing yourself. So really we're kind of talking about the growth mindset here. Many mental abilities are learned skills. Thoughtfulness is a learned skill. Empathy is a learned skill. Friendliness is something you can learn. I wouldn't have thought of myself as a very friendly people. Some people have told me I am friendly. I think I fake it pretty well a lot of the time. Maybe at this point it's been internalized a little bit. Lots of mental abilities are learned skills. So if you find something in someone else, if you find a trait in someone else and you want it, steal it. You can fake it. You can try to be that thing until eventually you act a little bit more in that way. So I want you to slow yourself down. Slow down your thinking, slow down your acting, slow down your speaking. I want you to take things one step at a time. I don't want you to distract yourself. I don't want you to distract the person who you're working with. Do the one thing that's important right now and then stop. I also want you to learn a little bit about learning itself. It can be useful for you, working more towards your goal of being a better mentor, but it can also be useful for your learner to understand these things. And I want you to adopt a growth mindset, not just for your own sake, but also for your learner's sake. Whatever being a good mentor means to you, you can move yourself in that direction if you put in the right kind of effort to do so. So I've pretty much only scratched the surface here on this topic. There's a lot of other resources on this in a lot of directions you can go in when you're kind of diving into this topic. I will share a URL with you at the end here that has a lot more information on teaching, on coaching, some other talks that have been given in the past on mentoring in a more broad sense as well. Be a learning ally, not an expert. Build trust with your learners so that they'll be more comfortable being vulnerable with you. And slow down and reflect on what it is you're doing and why you're doing it. Thank you.
So, I'm kind of sorry that we ran out of talks to give. But we still have sprints tomorrow, just a reminder, and I think you can still sign up. The information are all in the welcome wagon. It is at 400 Dexter Avenue from 9 to 5. And we have sprint coordinator, Timothy Crossley. Are you here, Tim? No, okay. He will be there tomorrow. And I plan to be there. I plan to sprint as well. Yeah, come. And I have a special, just want to spend some time, thank you to people who made this possible. And it's really easy to just say thank you, but I really want to spend the time because you all deserve this. First of all, thank you to the PSF. Pi Cascades is one of the first Pi Cascades is one of the first direct projects of the PSF, and PSF have supported us from the very beginning, providing us with all the resources, and thank you, the PSF, for supporting the community. And thank you to our sponsors, Google Cloud, Heroku, Nexmo, Twilio, Indeed, Rover, Metis, Real Python, University of Washington, Colony and Manning. Because of their sponsorships, we are able to keep prices low, affordable, so it is accessible to everyone. In addition, we're able to award $15,000 US dollars into financial aids, and 45 people receive diversity scholarships. They come for free, and our event is more welcoming and inclusive because of the sponsors. Thank you, sponsors. Thank you. Really, I mean it from the bottom of my heart. Thank you for being here today, for being away from your family, your home on a weekend. Thank you for being excellent to one another throughout this event. Thank you for your trust in us. There is no community without all of you here. The community is so much better because of you. So, thank you. Thank you to all our speakers for providing us with really quality content and very enjoyable. I'm sure you all are very inspired with all the talks. Thank you all. Now, for this next step, I'm going to start calling people on the stage. So if you see your name up there, please come on the stage. To all of our volunteers, I'm sorry, I can't call them one by one. If you see your name, please come. Come up here. Thank you to our volunteers, green room attendees, session runners, registration. Thank you so much. To all of the Welcome Wagon team, they have worked since, they've contributed a lot of content, very useful content, providing travel guides, sprint guides, recommendations of restaurants and everything else. And they've been updating with the links to the speaker slides as they have them. So they've been working really hard. Thank you. Stay, please. Please stay. Please stay. Please stay. I want you all to know how much work is put into this. Please stay. If you're not, your name here and you're not up here yet, please come up here. Special thanks to Elaine and Maggie. Here's my notes. All right. Because of the recordings and the live streams and the captioning, the messages of our speakers is heard not only here in this room, also in the quiet room, and all over the world. It's really important. Thank you so much. Thank you to our diversity and inclusion team, Mael as the diversity chair, and all of our code of conduct committee. Because of your guidance, expertise, and care, this event by Cascades is one of the most diverse and inclusive events out there. Thank you. To our program committee with Georgia as the program chair and all the reviewers. Alan. They received 230 talks, more than 230, I think, for 20 talk slots. It's not easy, but because of their experience, we are able to curate one of the most diverse and very high quality speaker lineup you can see anywhere. Really, thank you. It's not easy. And to all of our speaker mentors, if you're not up here yet, please come. It's partly because of you we received so many excellent talk proposals. Thank you. I don't know what to say. Okay. To our sponsorship and financial team who worked tirelessly throughout the year, not just the last month. They've been working with sponsors and with our vendors, working with financial aid, making sure we can include as many diverse people as possible here. It's a lot of work. Thank you. And lastly, Alan and Thea, please come up here. Thank you. It is with your leadership, your passion, dedication, and love of this community that we are here. Thank you. And I have a very special surprise for you. Please welcome Brad Cannon and Carol Willing, newly elected Python Steering Committee members. Thank you. Thank you. Thank you. Thank you so much. And Pi Cascades, the sequel, has finished. But since the very beginning, we know we're producing a trilogy. Production for the next Pi Cascades has started. We're coming to Portland next year. Thank you all again one more time. Thank you. We'll see you next year. Thank you. Thank you. All right. Let's take a group photo. Thank you very much.